My name is Maximilian Schwarzmüller and I will be your instructor in this course. Now, this course is about TypeScript, a superset to JavaScript, so a programming language which actually builds up on JavaScript. You could say it takes JavaScript to the next level. With TypeScript, you will see in this course, you can write less error-prone, much better and cleaner code, and also use some exciting new features which don't exist like this in JavaScript. Now in this course, you will learn TypeScript from scratch. You don't need to know anything about TypeScript to get started. Basic JavaScript knowledge absolutely suffices. You will learn all the basics of TypeScript, how it works, why we use it, the different advantages it offers. We'll dive into the core types it provides, and we'll gradually build up knowledge and dive into more and more advanced TypeScript features throughout this course. Now, this course is both a course that focuses on the theory and showing a broad variety of features, as well as showing all these features in action in real projects. Therefore, in this course, we'll have a real project. We'll also have a module where we dive into TypeScript with React. We'll also have a module where we dive into TypeScript with Node and Express. So that by the end of this course, you really feel comfortable using TypeScript in your next projects, and that you know why you would use it, and most importantly, how you would apply it to any JavaScript project you're working on. No matter, by the way, if that is JavaScript in the browser with or without any framework, or if it's on the server side. So that's all in the course. I'm super excited to start this journey together with you. And with that, I'd say let's not waste any time and let's find out what exactly TypeScript is and which advantages it has to offer. So what is TypeScript? What is it all about? Why would we use it? TypeScript is a JavaScript superset. Now, what does this mean? It means that TypeScript is in the end a language, a programming language, building up on JavaScript. It's not a brand new language. Instead, it takes the JavaScript language and adds new features and advantages to it. It makes writing JavaScript code easier and more powerful, you could say. But we have one huge disadvantage. TypeScript can't be executed by JavaScript environments like the browser. Browsers can't execute TypeScript, and for example, Node.js also can't execute TypeScript. So the environments where we can execute JavaScript don't support TypeScript. What's the idea behind TypeScript then? It's a better version of JavaScript and we can't use it? Well, not quite. TypeScript is a programming language, but it's also a tool. It's a powerful compiler which you run over your code to compile your TypeScript code to JavaScript. So what you get as a result when writing code in TypeScript is JavaScript, but you didn't write that JavaScript code. You wrote TypeScript code with all the new features and all the advantages, and you get normal JavaScript code. Well, that of course brings up one important question. How can TypeScript add new features if what you get in the end is regular JavaScript? And the answer is the TypeScript compiler compiles these new features to JavaScript workarounds. So in the end, it might give you a nicer syntax, an easier way of doing something, and it will then compile that nicer, easier way to a more complex JavaScript snippet which you would have to write otherwise. So it's not magic. Of course it can't add what's not possible at all in the JavaScript language, but it can add new features that simply are easier to use, nicer syntax, things like this. In addition, TypeScript of course does one important thing, which the name already implies. It adds types. It adds a feature to the JavaScript language, at which we'll have a closer look in a second, which will actually give you as a developer an opportunity of identifying errors in your code earlier before your script runs and the error occurs at runtime in the browser. So it does not only give you some new features and nicer ways of doing something, it also gives you extra error checking where errors, which you would otherwise get as runtime errors, can be caught and fixed early during development. So why would we use TypeScript? Consider this example. a fairly simple JavaScript function which adds two numbers. Now when I call it, please notice that I'm passing in two strings instead of two numbers. And I'll show you a real example where something like this could happen realistically in just a second. So we're calling this function with two strings, and as a result, what you would actually get here is probably an unwanted behavior, because if you add two strings, JavaScript will concatenate the strings instead of doing a mathematical calculation here. So the result would not be 5, but 23, a concatenated string of the two numbers. This is an error you could have in JavaScript. It's not a technical error, you probably won't get a runtime error, but you have a logical mistake in your code. And that, of course, can lead to huge problems in the web applications you're writing with JavaScript. Now, of course, in JavaScript, we have mitigation strategies. We could add an if check in the function to check the types of the inputs at runtime. We could also validate and sanitize user input. And whilst we might want to do all of that, it would also be nice if we could catch errors like this during development already. And thankfully, this is possible with TypeScript, because developers can write invalid code here and introduce bugs like this in JavaScript. And with TypeScript, we have a tool that helps us write better code and avoid such problems. So let's have a closer look at this. Here is this same example basically in a real project. You find this simple project, the index.html file and this JavaScript file attached to this video in a zip file. You can simply open this and then open the index.html file. You can also open the code in any text editor of your choice. Here I'm using Visual Studio Code, and I will come back to my exact setup later in this module. For now, you can just open these two text files with any text editor. Now what you'll find in there is this JavaScript file which interacts with this index.html file. And in that index.html file you find two inputs and a button, and in the JavaScript file, which gets imported here, we basically reach out to these elements, then we have a function here and an event listener on the button that triggers the function and logs the result of the function here in the console. Now, if we simply open that index.html file by double-clicking on it in the Windows Explorer or the Mac Finder so that it opens up in a browser, what you'll see is this, the two inputs and the add button, and here I opened the browser developer tools as well. Now, if you enter 10 and 5 here, for example, you might expect to see 15 as a result here on the right, but instead you see 105. And this shows us a weakness of JavaScript here. This is not a technical error, it's not an error which is thrown, but it's a logical error in our application. Now, where is this error coming from though? Well, here in JavaScript, I reach out to these two inputs, and when the button is clicked, in the end, I get the values of the two input elements, and I pass them here to add. And here it's important to know that in JavaScript, when you access the value of an input element, it's always a string, always, no matter which type of input this is, if this is of type number or not, it's always a string. So I'm passing in two strings to this function in the end, and if you add two strings in JavaScript, they get concatenated instead of added mathematically, which is why we see 105, 10, and 5 concatenated. This is the issue with JavaScript here, and this is something where TypeScript can help us. Now, without TypeScript, we could of course add a if check here and check if the type of num1 is equal to number, and if the type of num2 is equal to number. And if that is the case, then I return my calculation like this, else I might throw an error, or I at least convert both to numbers by adding a plus in front of each parameter here. Now, this is some code we could write, maybe a bit more refined than this, in JavaScript, and with that we would ensure that we convert numbers, or the inputs, to numbers if they're not numbers yet. So with that, if I reload this and I repeat this, now we get 15 because of our changed code. So of course you can do this in JavaScript, and this is vanilla JavaScript, nothing TypeScriptish about it. But we wrote some extra code for an error, which I actually would like to prevent in the first place. I don't want that this happens. I want to make sure that we can't even pass strings here to add, because add should be a function that only operates on numbers, so that in there we don't need to check whether we get a number or not. So I want to keep this function in the state it was before. I want this function here, just like this. And that is where TypeScript can help us. So TypeScript can help us in such situations as I just showed. Now, in order to see how it helps us, let's install it. So on typescriptlang.org, you can click on download, and there you learn how to install it. And we will actually install it with this command, which uses the npm tool, and the npm tool is part of the Node.js package. So even though we're not going to write Node.js code here, we still need to install Node.js, simply because behind the scenes that will also be used by some tools we use. And when we install Node.js, we also install npm, the Node Package Manager, a tool which we then can use to install TypeScript globally on our machine. So simply visit nodejs.org and there install the latest version you find here. Simply click on this button, it will then download an installer. You can walk through that installer. It is supported for all operating systems. And once you have Node.js installed, you will be able to run this command. Simply open up your normal terminal or command prompt and then copy in that command. Important on Mac and Linux, you might need to add sudo in front of this to get the right permissions. On Windows, this will not be required. So simply make sure you then install TypeScript with this command. Enter your password in case you should be prompted for it. And with that, you got TypeScript installed globally on your machine. Now, what does this mean? TypeScript installed. Well, remember that TypeScript is a programming language, but it's only a programming language that works because we also have this compiler, this tool which compiles it to JavaScript. So in the end, what we install here is the compiler and everything it needs to know to understand TypeScript code to convert it to JavaScript. So with this, we have the compiler installed, and we can run the tsc command now, which invokes this TypeScript compiler to compile a TypeScript file to JavaScript. So to see this, in this project we worked on, let's simply add a new file using ts.ts, for example. Any name you want, but the extension should be .ts, which stands for TypeScript. Now let's copy that JavaScript code into that TypeScript file. Here in Visual Studio Code, I immediately get some errors, which we now will fix. And this is one great advantage of TypeScript. If you're using the right IDE, and my strong recommendation really is Visual Studio Code, and I will come back to that later, then you already get great support in the IDE when working inside of TypeScript files. Here already it basically lets TypeScript analyze my code and identifies some weaknesses, which is great because that's exactly what I want. So here in this example, let me delete the JavaScript only JS file. And with that, some of the errors are gone because it identified that some constants and so on were used in multiple files, but it still gives me an error down there. And what you see, for example, is that it's not sure if there really is a value property. Now that's a mistake I didn't even consider before in JavaScript, but it's true. I'm selecting an element by ID here. Now, TypeScript can't know if this will really work. Maybe I have a typo in here. In this case, I wouldn't be able to select an element. This element simply wouldn't exist on the page. So we might have a typo, and TypeScript does not analyze your HTML code to find out if this works. So for one, this might fail. But even if it succeeds and we select an element there, it doesn't have to be an input element. It could be any other element, and most HTML elements don't have a value property you can access. And this already is great. TypeScript forces us to be more explicit, to be clearer about our intentions, and to double check our code. And for example here, and you don't need to understand all that syntax, we will learn it step by step throughout the course. But for example here, we could let TypeScript know that we are sure that we will get an element by adding an exclamation mark. This basically tells TypeScript this will never yield null. This will always find an element. And as a developer, I of course know that this will always find an element because I double check that ID and I see, yeah, I have that ID here. Now in addition, I also know it will always be an input element. So we can use as HTML input element a syntax called typecasting, which I will also explain in greater detail later, to let TypeScript know which type of element this will be. We can apply this to the second element as well. So just to be really clear here, this is TypeScript syntax. I can use this exclamation mark here and I can use this typecasting here because we are in a .ts file, we are in a TypeScript file. We will compile this to JavaScript. This would not work in vanilla JavaScript. This is not available there. With this, we are forced to be clearer about our intentions and to really think about our code and double check it, which is great. But that's not even the biggest advantage. The biggest advantage is the addition of types. That is what gives TypeScript its name, after all. And here, I'm not saying anything about the types of data this function operates on. If we hover over one of these parameters, we see this anything here. And in the end, this is TypeScript saying to us, I don't know what's in there. It could be any type of value. Now we can add a more explicit type in TypeScript files, so not in JavaScript files, but in TypeScript files, by adding a colon here and then specifying the type. For example, number. Doing this here and doing this here. With this extra syntax, which this compiler understands, we're telling TypeScript that this here will be of type number and this will be of type number. And therefore now we get an error here again. And we don't just get this error in the IDE, by the way. We also get it if we try to compile this code, because that is ultimately what we need to do, right? Now to compile this, I will open a terminal, and here I'm just opening my terminal or command prompt, which is integrated into this IDE. It's the regular system command prompt, the regular system terminal I was using here as well, just already navigated into this folder. So if you are not using some built-in IDE terminal, you can use your regular one, but cd navigate into that extracted starting folder where you added your TypeScript file. And once you are in that folder, you can run tsc, that will invoke this TypeScript compiler we installed earlier, on using -ts.ts. And if you run this, you will actually get an error. You will still get a JavaScript file because by default, TypeScript will still compile it to JavaScript. You will also learn how to suppress this later in the course. But it gives you a compiler error while doing so. It tells you that argument of type string is not assignable to parameter of type number. So the problem here is that TypeScript understands that what we get on the value property of our input element will be a string. We also see this here in the IDE. And we can't pass this to add, because there we don't want a string, we want a number. So we have to fix this by, for example, converting this to a number here by adding a plus. And as soon as we do this, we can compile this code again by repeating that command. And now it compiles without errors. It gives us this using TypeScript.javascript file. And now it shows some errors again because it doesn't understand that I will never use both files at the same time here. Again, this is also something which will get better later in the course. Once we configure this, we can ignore this for now. So it gives me this file. And if we open this, we see something interesting in here. We see that there, of course, our types are gone. This casting here is gone. We have vanilla JavaScript again. So if we have a look at our TypeScript file here, we see that there we have all these nice additions. But as I mentioned, these are just TypeScript features. When you compile to JavaScript, they are used to evaluate your code and to find potential errors, but then they are stripped out and we get regular JavaScript as output. So now we can go to our index.html file and import using ts.js, and that's important. Always import JavaScript files because the browser can't run TypeScript. We need to import the result of our compilation. And now with that, if we reload this, we have our working code because now we have proper JavaScript code where we fixed this issue by casting our inputs before we passed them to the function, but we were able to fix these issues because of our type annotations here. And as you saw, we had to write some other parts of the code in a cleaner way as well. And that is why TypeScript is amazing. It forces us to write better, cleaner, and less error-prone code. So you saw TypeScript in action, and it offers great advantages. It makes writing clean code really easier. TypeScript adds types, and that is super important. With types, we have to be way more explicit about how things work, and we can avoid many unexpected and unnecessary errors by using types. In addition to that, we also can use IDEs, modern IDEs, which have built-in TypeScript support, which can pick up on these types and give us better auto-completion and built-in errors which show before we even compile the code because they also understand TypeScript. But besides the types and the huge advantages we get alone by using types, we also get other features added by TypeScript. We can use certain next generation JavaScript features, which we can write and use in our TypeScript files, and then they will get compiled down to JavaScript code, to workarounds that even work in older browsers. If you know Babel, which is a tool that allows us to do that with vanilla JavaScript as well, it's a bit like that, just already built into TypeScript. We can use modern JavaScript features and still produce and ship code that works in older browsers as well. TypeScript also adds certain features which only TypeScript understands, like interfaces and generics. These are features which can't be compiled to JavaScript, but they don't have to because they are features that help us during development, that give us clearer errors and help us avoid even more errors. So it even adds more features on that front besides the types we already learned about. It also gives us certain meta programming features like decorators, on which I have a whole module in this course where you will understand what exactly decorators are, why they are so meta, and why they are amazing. TypeScript also is highly configurable. We didn't configure it thus far, but I have a whole module in the course where we talk only about the compiler and how to configure it. And you can really fine-tune it to your requirements to make it stricter or looser and to ensure that it behaves in exactly the way you want it to behave. And with modern tooling, with modern IDEs, you even get support in non-TypeScript projects. The IDE you just saw, Visual Studio Code, that even gives you better support in plain JavaScript files because it is able to use some TypeScript features under the hood without you explicitly using TypeScript. So that's a free gain you get out of the box when being aware of TypeScript and when using modern tools. So there are many reasons for using TypeScript, and that's probably why you took this course. In this course, we will now learn it step by step, and we will learn all about the amazing features it adds. This course is packed with content. We're almost done getting started, and thereafter we'll dive right into TypeScript and into all its exciting features and learn them step by step. We'll start with the TypeScript basics, of course, the core types, how it generally works, some of the new features it adds, and all you need to know to get a good understanding of TypeScript. Thereafter, we'll already dive deeper into the TypeScript compiler and the configuration of it, because it's super important for you to understand what you can configure there and what all these different settings do. So we'll have a closer look at that in this module. Thereafter, we'll explore next generation JavaScript features supported in TypeScript, how they work, and how you can use them in TypeScript. We'll continue with classes and interfaces, a super important concept, partly also in vanilla JavaScript, in the case of classes. But with interfaces, we also got a brand new TypeScript feature, and you will understand what they are, what they do, and why we might want to use them. Thereafter, it's time to dive deeper. We'll have a look at some advanced types and advanced TypeScript features in general, taking it to the next level there and building up on the basics we already learned about up to this point. Also an advanced feature, which definitely deserves its own section, is the generics feature. You will learn what that is and why it's really helpful in this module. Followed by decorators. Decorators are a pretty cool feature, also added by TypeScript, and we'll have a closer look at decorators and also build some really useful decorators in that module. And thereafter, we will have learned a lot about TypeScript. Now, the course is organized such that I show all these individual features in relatively small, simple demos. Now, to also give you a bigger picture and to see how you would apply all these features in a real project, we'll build just that. We'll have a whole module where we build an entire project entirely with TypeScript from scratch, so that you see many of these features, most of these features you learned about up to that point in action, and you see how they work together and why they simplify the process of building such a project. Once we're done building this project, we'll identify a new problem, and we'll learn how to solve it by working with namespaces and modules, which will help us make our code more manageable and readable. Building up on that, we'll also explore Webpack with TypeScript. Webpack is a build tool we use in modern front-end web development, and you can use it combined with TypeScript to get a better project setup, which simply makes certain things easier and allows you to get the best of both worlds, a great development experience and also code that works really well for your end users. Once we're done with that, we have a very solid picture of TypeScript and how to work with it in projects. Now, what you will need in a lot of real projects are third-party libraries. So we will take a closer look at that, because there are certain third-party libraries which really embrace TypeScript and have built-in TypeScript support, but there also are many libraries which don't. And we'll have a look at how we can work with both types of libraries in a great way in TypeScript projects. Well, and then there are some specific scenarios which deserve their own modules. We'll have a whole module about React with TypeScript, how you can build an entire React application with TypeScript only, and also an entire module about Node.js and Express and TypeScript, so that you also have great examples for these very popular and specific use cases of TypeScript, where you can suddenly create React or Node applications in a brand new way with a brand new language. So lots of exciting content in the course. Let's not waste any time. Let's see how you can get the most out of the course, and thereafter, let's dive in. Your success matters to me, and I want to ensure that you get the most out of this course. Now, of course, that starts with watching the videos. This is a video on demand course, so of course, watch the videos. You can go through this course step by step. It's built in such a way that all the modules and lectures build up on each other. You can also skip certain modules, of course, because all the modules also work on their own if you already know a concept, for example. Now, when watching the videos, of course, do that at your speed. You got speed controls here in the video player, and you can slow me down if I'm going too fast, or speed me up if I'm going too slow for your taste. I also recommend that you code along. It's not a must-do, but you typically learn better if you write code on your own, and you have to find and fix your own mistakes. Also pause and rewind the videos for that, because the videos are of course recorded in a way that also makes sense to people who are not coding along. So if you do, you might need to pause occasionally, try out the next steps on your own, or go back to an earlier point in a video to see how exactly I implemented something there. And in general, practicing is important. In this course, we work on real projects and we have many smaller demos. And I can only encourage you that you sometimes pause and try out the next steps on your own, or that you deviate from what I do and try out your own things. So definitely also advance on your own. Of course, only to a certain extent, because if you haven't learned about a certain feature, it might be hard to implement it on your own. But whenever possible, whenever you feel like it, definitely try out things on your own. Now, when you do that, or when you just code along as well, you will also face some errors. Things don't always go as planned, you introduced a mistake in your code, and you get an error. Now debug these errors and search on your own. Use the attached code, which you find attached to many lectures in the course, always to the last lecture of each module so that you can compare your code to mine and find out where it deviates. But also, if you get error messages, Google them or use the search here on Udemy to also search the Q&A section, because chances are someone else had a similar error and you can quickly fix it by looking at their solution. Now, of course, if you're really stuck or if some concept is unclear, you can also ask but also answer here in the Q&A section. I do my best to provide quick support there, but also try to help others there on your own. Because besides fixing your own errors, if you also help others and work with other students, you get a lot out of this course as well. So that's definitely also a recommendation I have. And with all these steps or all these building blocks, you have everything you need to get the most out of this course. Now in the next lecture, I will show you the setup, the IDE I will be using throughout this course, and thereafter we can already dive into TypeScript. TypeScript is amazing, but in order to work with it efficiently, I strongly recommend that you also have a powerful code editor, a powerful IDE. And here my clear recommendation is Visual Studio Code. It's free to use and it has amazing TypeScript support built in. Now, you still need to install the TypeScript compiler, and we already did this, but this has the built-in support which shows you a lot of errors directly in the IDE before you even compiled the project. So you can simply visit code.visualstudio.com, and there you can download it for any operating system and simply walk through the installer there to get this modern IDE. Now, it is the IDE I will be using throughout this course, and you can fine-tune and configure it to your requirements and needs. Here are just some settings I'm using. Under Code Preferences, you can change the color theme, and there I am using the Dark Plus theme. So if you want the exact same look, that's the theme I'm using, but of course you can also play around with any other theme here. I also installed certain extensions, so third-party plugins, so to say, which change the appearance or behavior of the editor. You can click on View and then Extensions to be taken to the Extensions menu or the marketplace, and it's all free, no worries, nothing here costs you money. Now I got tons of extensions installed, but the extensions I would recommend that you definitely have a look at is ESLint, that you install this to get linting, to get code quality check support in your projects, and that you install the material icon theme if you like these file icons I have in my projects. That's a pure visual thing, of course. It doesn't change any behaviors. And I can also recommend Path IntelliSense so that later in the course, once we work with imports, you get better support there. And Prettier, which helps you format your code so that it always looks nice and is readable. Prettier works together with a certain shortcut which you should be aware of under Preferences, Keyboard Shortcuts. There, if you search for Format Document, this shortcut here is a shortcut you can always press in your code to auto-format it, to add missing semicolons, to make sure you use the right indentation everywhere, things like that. It makes your code more readable and your life as a developer easier. And that's it. You can also install TSLint, but that will be merged with ESLint in the future, so ESLint should be all you really need. With that, we can go back to View, Explorer, and you should have the same settings I have here, but also dive into the settings in general and explore them and fine-tune everything to your needs and to your likings. And with that, you have a great editor which allows you to write great code, powerful code with a lot of built-in TypeScript support, and you're well prepared to get the most out of this course. So we set up the IDE, which is important. Now let's also set up a starting project, which we'll use throughout this course in the different course modules. So basically a project setup with which we can start every course module to then write our code there. Now, as you will see throughout this course, writing code doesn't require a complex setup in general, but here I want a project where we can write code, compile it, and then immediately see the output of that code in the browser. And for that, I'll first of all add a new index.html file, and you can add this in any empty folder. The two other files or folders you see here are just config files for Git in case you're using version control, and for my editor, which sets the zoom level. So that's all I have here. But in that index.html file, I will now initialize it with a base skeleton. And for that, in Visual Studio Code, you can just type HTML, choose that HTML5 option. If you're not getting this menu, just press Control and space. Choose the HTML5 option and hit enter, and you'll get this skeleton. There we could enter understanding TypeScript here as a title, but that does not matter too much. More important is that here you add a script tag in your head section and add a source and point at app.js here and add the defer attribute. This tries to import an app.js file, which of course right now doesn't exist, and it will then of course also execute it if it finds it. This allows us to view our changes, our code changes, directly on the screen in the browser, or if we're just logging something to the console, in the browser DevTools. Next, I will add an app.ts file. That's the file, a TypeScript file, where we will write some code. And there, for example, you could console log your code goes here, or whatever you want. You can console log whatever you want here. And if you do that, you can compile this file with TypeScript, which we installed earlier. For that, you can open the terminal, integrate it into the editor here, and simply write tsc app.ts. This compiles this TypeScript file and generates an app.js file now, which is the file we're importing here. And if you now open this index.html file, you see whatever happens in here. You kick off the logic you wrote in here. And either that's logic that manipulates something on the DOM, or like in this case, it's logic which simply gets logged to the console. So here in this case, I opened this HTML file in the browser. You can simply double click on it outside of the IDE, so in the normal Windows Explorer or the Mac Finder. And then maybe open your developer tools if you're just logging something to the console, and you'll see your log here. Now that's nice, but whenever we change something here in our code, we have to manually recompile. Well, that is what it is for now. It will change later in the course, but we also have to manually reload this page here. And to speed this up and make sure that you don't have to do this whenever you change something, we'll actually also add another tool here to this dummy setup, which we'll use throughout this course, so that this happens automatically. Now to install such a tool, let's run npm init here in this project folder. The npm command is available if you installed Node.js. Make sure that for that you visit nodejs.org and download and install the latest version you find here. For the moment, we're not going to write any Node.js code, but Node.js comes together with the npm tool, which we can use to install third-party dependencies or useful tools that speed up our development, and for that reason, we need it here. So with that installed, you can run npm init in this project folder. Simply hit enter, and you can answer all these questions here with the defaults by simply hitting enter all the time. And once this completes, it gives you a package.json file, which looks something like this. And now you can run npm install to install a dependency which is exclusive to this project. So to install a tool, you could say, which you can use in this project. --save-dev to mark it as a development only dependency, so a tool that helps us during development and does not contain any code which will execute as part of our main code. And the tool name is light-server. If you hit enter here, this installs this extra tool. And once this finishes, just go into your package.json file and in the scripts part, add a comma and add a new script which you name start. And then, as a value between double quotes, enter light-server. So that name of the package which was added here. If you now hit enter, you can run npm start here to start this start script. And light-server is a simple development server which always serves the index.html file next to the package.json file, so this file. And it serves your application on this URL you see here, localhost 3000 by default. And you can then just visit this location, simply enter localhost 3000 in the browser, and now your code runs here. And why is this better? Well, this will now automatically reload the page whenever another file in this directory changes. So if I, for example, add an exclamation mark here, and I save this, and I then compile this again with tsc app.ts, and you go back to the browser, you see the latest output immediately because it automatically reloaded. And that simply saves us the extra work of reloading manually. Now, important about this npm start process, definitely keep it running as long as you are working on your project, as long as you are writing code which you want to see execute in the browser. Once you're done, you can always quit this process with Ctrl+C, but once you do so, your project is no longer getting served under localhost 3000. So keep it up and running as long as you are writing code and making changes. With that, I'll change it back, but this is totally up to you. And this is the project setup I will use throughout this course. You also find it attached, of course, in the finished form. Just one important note, if you download the attached starting project or any other course snapshot, any other code snapshot you find anywhere in the course, then you will get a download that does not include this node modules folder. This is a huge folder which in the end stores all third-party packages and their dependencies. And since it is so huge, I typically delete it because you can easily recreate it by running npm install. So if you download one of my attachments, navigate into the extracted folder and in that folder run npm install. And this will install all dependencies and recreate this node modules folder. And once you did this, you can run npm start or do whatever you want to do in this project. And with that, we got this project setup we'll use throughout the course. Now let's not waste any more time and let's just get started. Now with the core basics, or with the getting started section out of the way, let's dive into the core TypeScript syntax, the core features. And that of course means we'll dive into the types, which types TypeScript offers and supports, and how we work with these types, how we assign types, how we can reap the benefits of using types, and all that fun stuff. TypeScript provides many types to JavaScript. Now, JavaScript itself also knows some data types, and I'll come back to that in this module as well, but TypeScript adds many more types. And as you will also learn in this course, TypeScript also enables you to write your own types. Now, let's start with some of the core types which JavaScript already knows and which TypeScript also supports. And we'll also have a look at what the difference between JavaScript knowing the type and TypeScript using that type means. One of the core types we work with in JavaScript and TypeScript is the number type. Now in JavaScript, and the same is true for TypeScript, there is only one number type. There is no special type for integers or floats. Instead, these values here would all be numbers. One would be a number without a decimal place. 5.3 obviously is one with a decimal place. And all these values are of type number. Other programming languages have special integer types and float or double types. JavaScript doesn't have that, and TypeScript doesn't have it either. So we have the number type, which we know from JavaScript, also as a type in TypeScript. We also have the string data type, and that would be text, which you can define in one of these three ways, with single quotes, with double quotes, or also with backticks. The last notation with backticks is a special syntax provided in modern JavaScript and also in TypeScript, which allows us to write so-called template literals that are normal strings where you can dynamically inject some data into them. So strings are simply text, and JavaScript knows about string value types. TypeScript does so as well. Last but not least, one of the core data types JavaScript knows and TypeScript also supports is the Boolean data type. That would be true or false, and that's super important in programming, obviously, especially when working with if statements. Here we got these two values, and that's important because in JavaScript you also might know this idea of truthy and falsy values. For example, that 0, the number 0, is a falsy value. If you use it in an if condition, it is treated as false. The Boolean data type really just knows these two values though, true or false. And that's not just the case for TypeScript, but also for JavaScript. This truthy falsy concept, which you should know, that is not related to data types. That's some behind the scenes work JavaScript does at runtime when it sees certain values in if conditions. So with numbers, strings, and booleans, we get a couple of core data types. Of course, not all, we got objects and so on as well, but let's focus on these types and see what TypeScript does with them, or what we can do with them with the help of TypeScript. For this, I'm back to the project we saw in the first course module, and there I showed you that all you need to do now is run npm start in a terminal, navigate it into this project folder to spin up this live development server, which will reload whenever we change something. And here I opened up this localhost 3000 address in a new tab of my browser. Right now I'm getting an error because I have no app.js file yet. Of course, you find this starting project also attached to this lecture. We'll get such an app.js file, which we're trying to import here in our index.html file, as soon as we compile app.ts from TypeScript to JavaScript. And we can do that in a new tab of the terminal, so that we keep this process running and open a new tab instead, by simply running tsc app.ts. And what this does is it compiles the TypeScript file and spits out a JavaScript file. And once that happens, we can reload this page and we get the time to get started output here. So now we have this setup here where we can write some TypeScript code and then compile it to JavaScript code to see what it does. Now with that, in the TypeScript file, I'll actually get rid of the content there, because now I want to dive into these core data types which I just showed you on the slide, so that you understand how to work with them in TypeScript. Now let's start very simple. Let's say we have a new function, add, and there we expect two numbers, n1 and add2, and I return n1 plus n2. Just like that. Very simple function, nothing TypeScriptish about it. Now we have two numbers with which we want to work. That could be number 1 here, which is say 5, and also number 2, which is maybe 2.8, whatever you want. Two numbers here. Now obviously, and not very surprisingly, we can add or call the add function and pass in number 1 and number 2 as arguments to this function, store the result in a new constant maybe, and then to see something on the screen, we can console log the result. If we do that, and I recompile this file with tsc app.ts, then this page should automatically reload already. If not, you can manually reload, of course, and you should see 7.8. Now, you might think that's not too special, right? This is a pretty straightforward JavaScript snippet, and indeed, there's nothing TypeScriptish about it. Well, let's do something which will break that snippet in normal JavaScript. Let's say this input here is actually not a number, but some text. A 5 in text. And if we now save that and rerun our compilation command here, you'll see that once this page reloads here, I get 52.8 as output. And that's obviously not the correct result of this addition. Now, do you know why we're getting this output in normal JavaScript, which we in the end are executing here? Well, we're getting this output because this is not the result of the mathematical addition, but instead this concatenates this as a string, because this input here, 5, is a string. And then JavaScript sees, okay, I got a string, I'm adding something to the string. Well, certainly this something should also be converted to a string, so that overall I got a string, because the first value was a string. And hence what JavaScript does is it converts 2.8 from a number to a string, concatenates a longer string from 5 and 2.8, hence yielding 52.8 as a string, and returns that. So it's not treating this in a mathematical way, but instead as a string. And with JavaScript, this can happen. Now, of course, you might think, why would I write such code? I'm the developer. Why would I make this mistake? Well, maybe you're not the one making this mistake. Maybe this is getting fetched from some user input, and you introduced a little bug in your code where you forgot to transform this. Or you're working in a team and you're having a couple of script files working together and some other developer introduced such an error. It's not impossible to make such errors, but it can be hard to track them down. Here, of course, it's pretty obvious that something went wrong because we have a basic script, but in a bigger script, you might not even immediately recognize that something went wrong here. And that's where TypeScript can help us. We can add type assignments in this function to our parameters. We can tell TypeScript that these two parameters should be of type number and not be of type I don't care, which is the default. So we do that by adding a colon here after the value to which we want to assign a type. So in this case, after the parameter name, and then the name of the type. For example, number would be one of the supported names. Besides number, you also got string or Boolean, but we'll come back to those. For the moment, we need number. And we don't just need it on the first parameter here, but also on the second one. So here also we can add a colon and then number. And now what we're saying to TypeScript is, hey, both parameters here should be of type number. Passing in values of a different type is not allowed. And indeed, my IDE already complains here because Visual Studio Code has built-in TypeScript support. But even if we would overlook this, as soon as I recompile this by rerunning tsc apt-ts, you'll see we get an error. We get an error that argument of type string 5 is not assignable to parameter of type number. And it even shows us where this happened and gives us the line number, line 8. And it's basically showing us the same the IDE shows here. So in case we overlooked it in the IDE, compiling it now throws an error. And that's the important thing about TypeScript. It only helps us during compilation. It doesn't change JavaScript to work differently at runtime because browsers have no built-in TypeScript support. It can only help us during development before we compile our TypeScript code to JavaScript. But there, it's extremely useful because it adds an extra step, an extra sanity check, where here we find out, oh, we made a mistake. Here, this shouldn't be a string, this should be a number. And we can fix this and we're good. This is what TypeScript does. It helps you during development. It does not change your runtime code. Indeed, here, even with the default settings, it compiled our error here, even though it detected it during compilation, and created a file which causes the incorrect result. Because by default, TypeScript does not step in here. Later, you'll learn how you can make sure that it does. But by default, it doesn't even block compilation. Still, it yells at you and points at this mistake, so that you can fix it and so that you can avoid such mistakes here. By the way, make sure you don't have app.js and apt-ts open at the same time. You could get errors here in the IDE regarding duplicate function implementations. Closing the JavaScript file fixes this. So we already see how TypeScript can help us during development. Now, we also know that there is a number type in JavaScript. And we can see it with the built-in type of operator. This is now not TypeScript specific. This is a built-in operator and keyword supported by JavaScript. We can use it to get the type of a certain value. So here we could console log type of number 1. And what we'll see if we do that is that as soon as we compile this so that we run the updated code, here we print number to the console. Now we do that thanks to this output here and thanks to the type of operator. And in vanilla JavaScript without TypeScript, we could use that to also improve our function here. We could check if type of number is equal to number, type of n1 I mean, if that is equal to number, and we could also check if type of n2 is equal to number, and only perform our operation here if it is, and otherwise throw an error, or do the opposite and check if it's not equal, or if n2 is not equal, and if either of the two is not a number, then we could throw a new error where we say incorrect input. This actually would be a non-TypeScript way of ensuring that we can't call this function with a string here. If I do this now and I recompile, we get our TypeScript error, but let's ignore that for now. If we rerun this, we get the incorrect input which we're throwing ourselves. So now we hardened this function in JavaScript. It fails at runtime, but failing might here be better than showing an incorrect output which we had before. So this would be a way of checking the inputs in just JavaScript. You don't need TypeScript for that. That's regular JavaScript code. But of course, this approach has downsides. Sometimes it's the right thing to do. Sometimes you only can validate certain inputs at runtime. But the downside is here, we're checking something which we actually can avoid during development with TypeScript. So yes, we're throwing an error, and in our application we might have built-in measures that can then fall back to some other behavior to save the running application, but still we're throwing an error which is really not necessary to occur in the first place. We could have prevented it with TypeScript. And here we really see the difference between JavaScript and TypeScript when it comes to types. JavaScript is dynamically typed, which means it's perfectly fine that we have a variable which initially might hold a number where we later assign a string to it. And that's why we have the typeof operator so that we can check the current type of something at runtime if we have some code that depends on a certain type. TypeScript, on the other hand, is statically typed, which means we define the types of variables and parameters and so on during development. They don't suddenly change during runtime. Now, of course, since TypeScript is compiled to JavaScript, they theoretically could, but if we use TypeScript and we write code where we suddenly assign a new type of data into a variable, where we previously set that this should be a number, for example, and now we're assigning a string, then we get an error during development so that we are forced to be clear regarding the types something can or cannot hold. That's the difference here. So we don't really want to use implementations or solutions like that if we can avoid it with TypeScript. Still, it's important to know that JavaScript, of course, knows about the concept of types. It knows about some types like number, string, and Boolean. But using that always means that we can only fail at runtime instead of during development, which is a better place for us as a developer. It allows us to fix bugs earlier. And in addition, JavaScript only knows about a couple of types. As you will learn throughout this course, TypeScript knows about way more types than JavaScript. So this runtime checking is really not as flexible or not as powerful as what we can do with TypeScript. And for all these reasons, this approach is actually not the approach we want to use here. Sometimes it can be useful to get the type at runtime, but sometimes, like in this example, it's way better to get it during development. The only important thing to recognize, of course, just is that with TypeScript, you only get the support during development, not at runtime, because these TypeScript features and checks are not built into the JavaScript engine, so that logic can't execute in the browser. It can only execute during development when you compile your code. So now that we know about TypeScript fundamentals and how it differs and also is related to JavaScript, let's dig a bit deeper into the different core types TypeScript knows. The number is the type we see here, and as I explained, there is no difference between integers, like the 5 here, and floats or doubles, as it would be called in other programming languages, like the 2.8 here. Indeed, in JavaScript, and the same is true in TypeScript, all numbers are floats by default. So for JavaScript, and therefore also for TypeScript, there is no difference between 5 like this and 5 like this. It's the same number essentially. Now, besides numbers, we also have other core types, and that would be strings, so text, and Booleans. So let's also have a look at those. We actually saw all of those in action here in this if statement already, which we learned is a bit redundant. Nonetheless, this here would be a string. Also, of course, 5 with quotes would be a string because it's text. And the result, for example, of this comparison here, that would be a Boolean. This operator, the triple equal sign, or the negated equality operator here, that produces true or false. And of course, we can either produce it dynamically in a if check, which we'll often do, or we initialize a variable with a true or false value. So let's do both here. Here we could add a new constant, print result, and set this to true, for example. And just to make it really clear, this could be a variable as well. It doesn't have to be const, it can be a variable, which you would create with let in JavaScript. But since I don't plan on changing it here, I'll go with a constant. And we could pass this as a third parameter here. Let's say we pass in print result, which holds true here. Now, we immediately get an error, of course, because our add function does not support a third argument. We see expected 2 arguments, but got 3. So therefore, we have to make sure we support a third argument. And there we could add a show result parameter. You could name it print result here as well. I'm going with show result to avoid confusion regarding the naming, but technically these two names would not clash. So here I'll name it show result. And I want to make sure that this is of type Boolean by setting this to Boolean. Again, by adding a colon after the parameter here, and then by adding the name of the type. Now this function accepts this, and now what we can do is we can add a if check here and check if show result. If this is true, we can of course compare it to true, but as you know in JavaScript, you can also just pass in the truthy or falsy value here, and JavaScript will evaluate it. And if this yields true somehow, or a truthy value in general, then we'll make it into the if block, otherwise we won't. And let's say we do make it in here, and then I want to console log n1 plus n2. Otherwise, in the else case, if we don't make it in there, then I want to return this. So now this is a function which sometimes returns a value and sometimes does not return a value but output it immediately. Now, you could argue if you want to write such a function which is kind of unpredictable or which might behave unexpectedly if you're passing in true here, but here we're doing it. So this function only sometimes returns, sometimes it also does not return, but instead just logs something to the console. Now here we can actually call add just like this and don't need to store it in result and don't need to console log result, because with print result set to true, add itself, so the function itself will print the result. Hence, if we now save that and we recompile our app.ts file here with the tsc command, once this is done, the page will reload and we still see our output here, but now it's coming from line 6. And if we have a look, line 6 is indeed inside the function. So this is a Boolean. Now let's say we want to customize the output, and therefore we have a result phrase constant here where we say result is colon and then some white space, and we pass that in as well with result phrase here. Well, then we could expect this as an argument here as well, phrase, which should be of type string, by adding a colon, and then string is the name of the type. And now we could use that phrase to output it as part of our result output if we're printing the result right in the function. So then here we could have phrase plus n1 plus n2. And if we do that and we recompile by repeating that command, we'll see that this phrase is part of the result. But we also now reintroduce the old bug. Because I have a string which I combine with two numbers, everything is converted to a string here. And that's not what I want. To avoid this, in this function, we could add a result variable here, or a result constant, and store our result here. This will now be treated in a mathematical way because only numbers are involved. And then here we could combine that with phrase or just return it. And now, since this is never directly calculated together with a string, this will always be a number. And yes, then here this number combined with a string will be converted to a string, but since the mathematical calculation finished before that, we'll have the right result. So now if we repeat that and I recompile, we get the right output. So now these are the core data types in action. Let's now make sure we fully understand how types are assigned and also why we don't explicitly assign types down there. So we're using the core types of number, Boolean, and string. And here in the list of parameters of this function, we're always explicitly assigning the types with a colon after the parameter name and then the name of the type. So here the names are number, Boolean, and string. And in case you were wondering, these are now special identifiers. This overall here is a special syntax which is added by TypeScript. It's not part of the compiled JavaScript code. If we check that code, here these type assignments are gone because JavaScript does not support them. This colon thing after a variable or after a parameter, and then number and Boolean and string, these special keywords, this is introduced by TypeScript. The TypeScript compiler understands it. The IDE here supports TypeScript and therefore doesn't complain about these special keywords. JavaScript does not understand this syntax. It doesn't understand a colon after a parameter or a colon after a variable and then the special number or string keyword. JavaScript doesn't understand this, and therefore this is not part of the JavaScript output. It's really just used by the TypeScript compiler, and then, well, it is a compiler because it converts this code to JavaScript code. Side note, you also see it switches const for var, but that's something I'll come back to later. So we have our explicit type assignments here, and it's only understood by TypeScript. Great. Why don't we have them down there? I don't have explicit type assignments here, and by the way, also not here when we calculate the result, for example, because TypeScript has a built-in feature which is called type inference. This means that TypeScript does its best, and it does a pretty good job there, to understand which type you have in a certain variable or a constant. And here, for example, it understands that number 1 will always be of type number in the end because you initialize it with a number. Now, this actually is a constant, so it's even more specific than that, and the type it identifies here is not just any number, it's the number 5. Because you'll not be able to assign a new number or a new value to a const value anyways. If we would change this to a variable, so if you would use let instead, then of course this would not break anything. We can use a variable there. It might not be best practice because this value never changes, but it's also not horrible. But now if we hover over this, we see TypeScript doesn't say, okay, this has to be a 5, but still it detects that the type here is a number. Now we absolutely could write this code here on our own. We can add a colon after the variable name on the left side of the equal sign, and then the name of the type. So basically the same we did in the parameters of this function. But this is redundant, and it actually is also not considered to be a good practice, because TypeScript is able to perfectly infer this type from there. So assigning this is not a good idea. This only changes if you would create this variable in an unassigned way. Like this, if you don't initialize it immediately. Then it's a good practice to tell TypeScript which value will eventually be stored in there, so that when you later assign a value to it, and of course it's a bit redundant here to split this in 2 lines, I'm just doing this for demo purposes, but now if I assign this here, this works because I told TypeScript in advance that this will be of type number. You don't have to do that, it also works if you don't do that, but now you could also add this 5 and you wouldn't get an error, because you're not telling TypeScript anything about the type which will be stored in this variable, and therefore TypeScript allows any type. If you instead add colon number here, you're telling TypeScript, hey, eventually a number will be stored in there, and hence if you later store something else in there, like in this case where we store a string, you'll get an error here in the IDE, and of course also if you compile your code, you will get the error we already saw before. So this is how you can assign types. Now, even if TypeScript just inferred a type, and let me fix this, it will yell at you if you break that inferred type. Actually, it's wrong to say even, because of course it does. Why would it not do that? Type inference is there for you to save you code, to avoid that you manually have to assign a type. Of course, TypeScript yells at you if you then use a wrong type, a type that it did not infer. For example here, if result phrase is created with let, so that it's variable, then TypeScript here infers that this will be of type string, because we initialize it with a string. So this is basically the equivalent to not initializing it and setting the type on our own, and then assigning a value later. Now if we change result phrase to, let's say, 0 here, for whatever reason we might want to do that, well then we get an error here, that type 0 is not assignable of type string. And that makes sense, right? TypeScript inferred that we want to store a string, we're now trying to store a number, we get an error. That's the job, the core task of TypeScript, checking types and yelling at us if we're using them incorrectly. Let's dig deeper into the core types TypeScript supports. The next type that's interesting is the object type. Now, you know objects in JavaScript, they look like this. You have curly braces and then you have key value pairs in there, and such values would also be treated as object types in TypeScript, so any JavaScript object is of type object, though I will already say there are more specific versions of objects in TypeScript, so that you can say this is not just any object, this is an object which has to have these properties, or which has to be based on this or that constructor function. But we'll get there step by step. To dive into objects, I'll first of all rename app.ts here, and I'll rename this to basics.ts. app.ts here and add a new app.ts file, which will then overwrite the old app.js file once we compile it, where we can now dive into objects. And let's start by creating a basic object here. Let's say a person with the curly braces here, and we give this a name. Here I'll go with Maximilian because that is my name, and the age of 30. Now, of course, we can console log person here. And if we do so, and we compile this, unsurprisingly, we should see that object being printed here in the console. Now, what we also can do in JavaScript is we can try to access, let's say, nickname, a property which does not exist here. Now, you immediately see that TypeScript is not too happy about that, and hence my IDE tells me. It tells me that property nickname does not exist on that type. So if we save that, and I try to compile that, we indeed get that same error down there. The TypeScript compiler does not like this, and it tells me that we have no nickname property on this object. It finds out that we don't have this nickname property because if we hover over person, it inferred, we can see there is a colon after person, so after the variable or constant name, it inferred that this is the type of data which is stored in there. Now that's not just object, as you can tell, that is a concrete object. It's an object with a name key, where then the type in turn has to be a string, and the age key, where the type has to be number. And actually this can be confusing here. This here obviously looks like a JavaScript object, curly braces, key value pairs. Well, the first important thing to see here is that we have a semicolon here after each line. We don't have that in a JavaScript object, we have a comma here. And indeed, this is not a JavaScript object here, which is created somewhere. This is the object type inferred by TypeScript. And object types are written almost like objects, but of course we don't have key value pairs there, but key type pairs. Object types are there to describe, well, the type of object that is getting used somewhere. We could be more generic. I could explicitly assign a type here to the constant of object. Object is one of the built-in types, just like number and string. And now if I hover over this, we see persons of type object. And now TypeScript really only cares about the fact that this is our object type. Now still, if we compile this, we get that error though, because TypeScript still analyzes our code and sees that we try to access something which doesn't exist there. But it's important to understand that it all starts with this most generic object type. But often you want to be more specific than that. You don't just want to work with that generic object type. You really want to get the full support. For example, right now if I add a dot here and I have a look at my auto-completion, I get no help there at all by my IDE. Reason for that is that all we tell the IDE is that we have a value here in person, which is of type object. Indeed, now we actually also get an error if I try to access name. Name exists here, right? But what we tell TypeScript here is that we just have an object where we don't give any other information to TypeScript. So actually TypeScript doesn't support any type of property because we don't tell it anything about the object. So we should be more specific. And we are more specific by setting a specific object type, the thing which TypeScript also inferred automatically. We do this by adding curly braces here after the colon, after our const or variable name. So this here does not create a new JavaScript object. This will actually be stripped out of the compiled JavaScript code. Instead, this is just TypeScript's notation of a specialized object type, so to say. So of an object type where we provide some information about the structure of the object. Now, by assigning just an empty pair of curly braces as a type, we essentially do the same as with object. We tell TypeScript that this is some object. Now we can be more specific though. We can add key value entries here, however, not key value, but key type instead. So here we could say the object which should be stored in person should have a name property, and the value of that name property should be of type string. So here we describe the type of value which will eventually be stored in name. Now, by the way, you see I'm getting an error here, because what I'm telling TypeScript now is that my person should have an object with exactly one key value pair where the key is name and the value of that key is string. but we then assign an object with two key value pairs. Name, which holds a string, that is fine, but age, which holds a number, and that would not be fine. So here we have to adjust this by adding a semicolon and then adding another key value pair here where we say age should be of type number. So not 30 here, that actually would be supported in TypeScript, that we restrict it to one specific number, but then we'll run into issues as soon as we change that. Instead, here I just want to say age should be some number. And now we basically are explicitly assigning the same TypeScript inferred before. As you learned, that's not a good practice, but to understand object types, I wanted to do it here. Still, this is something you can do. It's better to let TypeScript infer this as we did before, like this. Now, just to show something interesting, if I switch back to the suboptimal code, where we explicitly assign a type TypeScript would be able to infer, if we compile this code, of course, it works, we can access the name property, but if we then have a look at app.js, we see this type assignment is removed here. And that, of course, should be something expected. As I mentioned, types and type assignments are not part of JavaScript. They're TypeScript only. I just wanted to show this again to make it really clear that this syntax here is not creating some JavaScript object which is somewhere in our code. This is just TypeScript's representation of an object type that helps TypeScript understand the objects you're working with. The better syntax, of course, is this syntax, as you learned. Now, besides objects, we also have arrays in JavaScript. Very important type of data. Arrays are created like this in JavaScript, as you know, and you can store any data in there. Numbers, strings, booleans, objects, other arrays. You can have nested arrays after all. And you can also mix data. You can have an array with strings and numbers mixed. And TypeScript also supports arrays. Any JavaScript array is supported, and the types of that array can be flexible or strict. Now let's have a look at that in TypeScript. For that here in app.ts, let's say our person also has a hobbies key. But of course, we could also have a variable or a constant hobbies outside of the object. So using arrays is exactly the same inside of objects and outside of them. So here we have hobbies, and hobbies could be sports and cooking, let's say. So I have two elements in there, and these elements, as you can tell, are strings. Now, if we hover over hobbies, TypeScript correctly detected that this is of type string array. Now, that's a syntax you haven't seen before, but this is how TypeScript describes an array of data. You have the square brackets, and in front of that, the type of data which is stored in there. Now, this is the type TypeScript inferred. It saw that here we have an array and that we only have strings in there, so it inferred that hobbies probably should be an array of strings. And indeed, for hobbies, that makes a lot of sense. Of course, you can also explicitly set the type of a variable. If we would add a new variable, favorite activities, and initially that should be empty, then we might want to explicitly set the type of data stored in there. And now let's say that should be an array of strings. Well, then we can just repeat what we just saw. Type string, and then square brackets thereafter. And this tells TypeScript what we store in here is not just a single string, it's an array of strings. And indeed, if I try to store just sports in there, I get an error. I get an error because that here is a single string and not an array of strings. I don't get an error, of course, if I wrap this into square brackets and therefore effectively I create an array. I again do get an error though if I add a number, let's say, because we defined this to be an array of strings. Now here we have a mixed array. It's an array of strings and numbers. So that does not work and is not supported here. If we would want to support such a mixed array, one solution would be to use any here. The any type is a special type in TypeScript, which we'll have a closer look later, which basically means do whatever you want. It's of course a type you don't want to use too often because you'll lose the benefits TypeScript gives you. You're back in JavaScript world, where you also can use any value anywhere. So any is really flexible, but the flexibility comes at the price of basically giving up all benefits TypeScript offers. So here I want to go back to string because I really don't want to have a number in there, and hence we can remove the number and we're good. Arrays also give us a great example, actually just like objects and their properties, how dynamic TypeScript's type inference is. If we add a for loop here at the bottom, and we want to go through all the hobbies of person, we can of course use a traditional for loop with for const hobby of person.hobbies, so accessing the hobbies property and going through all the hobbies there, storing each hobby for each iteration in this constant, and then we can console log hobby here. Now that's not too fancy, that's something we know from JavaScript, right? If I now compile this app.ts file down there, we get the name from this line and thereafter the 2 hobbies being printed. But what's actually interesting here is that on hobby, we can access anything we can access on any string. For example, to uppercase. I get this auto completion and TypeScript does not complain. Why does it not complain? Because it knows that hobbies is of type string array. So when I access person.hobbies, TypeScript's inference detects that hobbies will be an array of strings. So hobby, on the other hand, is correctly identified as being a string, because since we go through an array of strings, well, the individual values have to be just strings. And therefore TypeScript offers us great support down there and allows us to do anything with hobby that can be done with a string, because it knows with certainty that hobby will be a string because of the types we set up there. And that's really flexible and of course a great feature which makes writing code a lot easier and way more flexible and secure. For example, we would get an error here if I would try to access hobby.map if I thought this would be an array. The map method is available on arrays, but not on strings. And here correctly I get an error that map does not exist on type string because it doesn't. So here we get an error, and that's good that we get it, because this would be wrong. And here we see TypeScript's inference really shine. So arrays are supported, and with numbers, strings, booleans, objects, and arrays, we got the core values or value types JavaScript knows supported in TypeScript. As you will learn at the example of objects and arrays, TypeScript even offers way more functionalities there, but that's a bit more advanced, which is why we'll have a look at that later. But even these core types, with what you'll learn in the previous lectures, are supported. Now TypeScript also adds a couple of new concepts, new types, which we don't know from vanilla JavaScript. For example, the tuple type. Now, you might know tuples from other programming languages. JavaScript does not have them. This is a tuple, for example, and you would say, well, this is an array. It is an array, but it's a fixed length array, and actually not just fixed length, but also fixed type. Now, where could this be handy? Let's say here on our person, we actually have another property, role, which is an array with exactly 2 elements, where the first one is, let's say, a numeric identifier, like 2, and the second one is a string identifier and a human readable description, like author. Now, this should always have exactly 2 elements, because a user or a person in this application, which we're writing, let's say, can only have 1 role, and a role is only made up of 2 elements. Of course, we could have used an object here, but for some reason we want to have an array with exactly 2 elements, where the first element always is the numeric identifier, and the second element always is the string identifier, or description, or however you want to call it. Now, if we hover over this, TypeScript actually infers this strange type, which we haven't seen before. Effectively, this means TypeScript understands that we have an array which might hold either strings or numbers. This is a union type, and we'll dive into those later. The key takeaway is that TypeScript understands that this should be an array with these types of values. The downside is that we could run this code though. Person role push admin. Now, for our application, this might not make sense because we know we only need 2 elements. Still, TypeScript doesn't know that we only want 2 elements. We would also be able to switch person role, the second element with index 1, to be a number as well. This would work because TypeScript only knows that role should be of type string or number array, and therefore assigning a number here to the second element, and therefore replacing it with a number would be allowed because we're just saying something about the types we generally can use in there. We know we want to have exactly that structure. 2 elements, first element number, second element string, but TypeScript doesn't know that. Well, for such a scenario, a tuple would be perfect. We can tell TypeScript what role should be by explicitly setting the type of role. So here we also have an example where TypeScript does infer a type, but we explicitly want to override it. Now here we can therefore add an explicit object type by adding a colon after person, then the curly braces, and then name should be a string, age should be a number, and hobbies should be a string array. So all as inferred by TypeScript. So for that, we wouldn't have required this explicit assignment, and as you learned, it would have been bad. But now we have a scenario where the inference does not work in the way we want. And we want to set role to be a tuple. Now, instead of setting it to string array or number array, or using the same type that was inferred here earlier, we can now use a special type. We use square brackets again, but now inside of the square brackets, we add number, and then a comma, and then string. Now, this marks a tuple type here. A tuple is a special construct TypeScript understands. In JavaScript, it will be a normal array, but during development with TypeScript, we'll get errors with code like this here. Now, what do tuples do? This here tells TypeScript, I want to have a special array with exactly 2 elements, because I have exactly 2 types in there. And the first element should be a number, the second element should be a string. Hence, if we compile this code here, I get an error regarding 10 not being assignable as a type here, because we want to have a string as a second value. And if I then assign 10 as a second value here, then I obviously don't follow this rule. Now, if we comment this out and we compile, this works. That's a bit strange, because why does pushing work here? Because we're also saying that role should have exactly 2 elements. So why can we push admin onto the role array here? Push actually is an exception, which is allowed in tuples. So unfortunately, TypeScript can't catch this error, but at least it ensures that we're not assigning a wrong value here. And outside of push, we also get some support regarding the length. If we set person.role to a new value, for example, an empty array is not allowed. One with exactly the structure we defined up there is allowed. If I added an extra element here, then we would again get an error. So the length is enforced if we assign it like this, but not for pushing and so on. This is something you have to be aware of. But still, getting this support and this support is pretty nice. And if you have a scenario where you need exactly X amount of values in an array and you know the type of each value in advance, then you might want to consider a tuple instead of an array to get even more strictness into your app, to be even clearer about the type of data you're working with and the type of data you're expecting. Loosely related to the idea of a tuple is the idea of having a couple of specific identifiers, global constants you might be working with in your app, which you want to represent as numbers, but to which you want to assign a human-readable label. And for that, you have the enum type. Again, that does exist in some other programming languages. JavaScript doesn't know it, though. It looks like this. This is how you create an enum. You use the enum keyword, which only exists in TypeScript world, not in JavaScript. Thereafter, you have curly braces and then your identifiers. And this type, which is added by TypeScript, gives you an enumerated list. So these labels are in the end just translated to numbers starting at 0, where you have human-readable labels you can work with in your code. To show you an example, let's go back here to our person with its role. I'll copy that code and then comment it out because I'm going to change it a bit. And then here, I'll get rid of that explicit type assignment and instead go back to Inference because I'll now change role. And now let's say we want to have an admin, an author, and maybe a read-only user. The admin should have an ID of 0, read-only user has 1, author has 2. Now, of course, we can store that exactly like this with these numbers. One downside is that we can also add a number for which we might not have a role, and if we then later in our code try to extract a role and use it in an if check, this might lead to errors. And in addition, we as a developer have a hard time to understand which role this user has. Was Q the author or was it the read-only user? You might forget this after making longer pauses, when working in bigger teams, and so on. So as a developer, we might want human-readable identifiers, something like admin and read-only user, something like that. Now, of course, we could use that. We could work with such string values. The problem is if we then later need that in an if check, we check if person.role is equal to, was it read-only user or was it one word? Was it with underscores? You see, then we have to remember how we wrote these strings, which exact text we have in there. Because this string with the dashes between the words is of course not the same as this string. So here we would never make it in there. Is read-only if we try to compile and print that, because, well, the check simply doesn't yield true. We don't have that as a role on person, hence we don't get the output here in the console. So string identifiers also have downsides. Now for such scenarios, it's quite common in JavaScript to define global constants, for example admin, which then hold certain values like numbers or strings. Both is possible. Numbers, of course, can save us some extra code and bits in memory. And there we might have admin, read-only, and author, like this. And down there, we then just have to use that role. Now, the advantage of that is that we can use this everywhere in our code. And therefore here, for example, if I run this code, if I compile it, and then we let this reload, we see is admin here. So this works, and this is a common pattern in JavaScript. Downside is that now again, role is inferred to be just a number. So we could store any number in there, even a number which we don't support. And in addition, we have to define all these constants. We have to manage them. This is where an enum can save us work. This is totally fine, but an enum makes it easier. We create an enum with the enum keyword. We can name it role. Convention is to start with the uppercase character because an enum also is a custom type. It's your first custom type. You're going to write many more in this course. This is the first one. And then after the name of the type you want to assign to this enum, you add curly braces, just like that. No colon, no equal sign, just curly braces after the name. Then a semicolon. And now in here, you can assign your values like admin, read-only, and author. And behind the scenes, this here receives the number 0, this here number 1, this here number 2. And then here you can access role.admin, like on an object you access your identifier, and you can use that anywhere else in your code as well. Here we can check if the role is author, and then print author. And of course we shouldn't see that if I run that now because we assigned a role of admin here. But the key takeaway is that we did all of that with the help of the enum, which assigns labels to numbers. If we have a look at that in JavaScript, so in the compiled code, we see this is how it's rebuilt. In the end, it's rebuilt with a iffy here, so a function which executes itself. And role here simply is managed as an object in the end, which has an admin property, a read-only property, an author property, where we then store our number values here, you could say. So it's a bit more complex than that, but that's what TypeScript in the end does here to replicate this enum construct in JavaScript code when it compiles the code. Here as a developer, we simply have these conveniently created numbers. If you hover over them, you see the number which was stored in there, and you can use these numbers here in a human-readable way. Now for enums, you're also not restricted to the default behavior. Let's say for some reason you don't want to start with 0 as a starting number, then you can add an equal sign here after your identifier and enter any other number, and now admin is assigned to the number 5, and the other identifiers after the identifier where you assigned a value pick up on that and simply increment this starting value. So now we have 5, 6, 7 instead of 0, 1, 2. You of course also can assign your own values to all these identifiers if you need your own numbers. You're also not restricted to numbers. You can also go with text here or even mix it like I'm doing it here. Anything goes there, but often the default of incrementing numbers that start at 0 is what you want. But if you need a different behavior, if you wanna use a string in here and then a number here and here a number as well, or maybe another string, then you can absolutely do that. The advantage is you define it up there, and then thereafter you always just refer to your role type, to this custom type you created, to this custom enum you created, and you use that in your if checks, in your type assignments, and you're good. That's the power of the enum, and it's a great construct whenever you need identifiers that are human readable and have some mapped value behind the scenes. With that, we're almost done with the core types. There is one more type which we already saw, and that's the any type. The any type is the most flexible type you can assign in TypeScript. This type doesn't tell TypeScript anything. It basically means you can store any kind of value in there. We got no specific type assignment. TypeScript will basically never yell at you when you use any. Back in our code here, if I would set the type of favorite activities to any, would not get an error. If I set it to any array, I at least tell TypeScript that favorite activities is an array of something. So if I would store just a single value in there, I would get an error. But as long as it is an array, I can store whatever I want in there. So any is really flexible, and this can sound great at first, but actually it's a big disadvantage, and you absolutely want to avoid any whenever possible, because any takes away basically all advantages TypeScript gives you. It gives you the same experience you have with vanilla JavaScript, where you also have the any type on everything, so to say. Any basically makes sure that the TypeScript compiler can't check anything, because if any property or any variable can store any value, well, then there's not much to check, right? So you can use any as a fallback if you have some value, some kind of data where you really can't know which kind of data will be stored in there, and where you then maybe are using some runtime checks, like we did here, at runtime to narrow down what you want to do for certain values. Then you could go with any. But in other cases, you really want to avoid any. If you have a chance of knowing which kind of data you're working with, be explicit about it. Let TypeScript's inference do its job, or explicitly set your own types. Don't fall back to any if you don't need to. So we covered a couple of the core types TypeScript knows. Now let's move on. And for that, I'll rename app.ts here to objects, arrays, enums, or whatever you want to name it, basically so that we still have that file, but I'll create a brand new app.ts file so that we have an empty file again in which we can work. Now in this file, I want to dive into another interesting type which you find in TypeScript, and that's the union type. Now what's that? Let's come back to our add function which we wrote earlier. I'll copy that and move that into app.ts, get rid of that comment here. And here on add, let's close basics.ts so that we get rid of that error. Here in add, I now want to be more flexible regarding what we accept here. I will also get rid of show result and phrase. I don't need that. And the only thing I want to do is I want to calculate a result and return it, but I want to be more flexible regarding the inputs. Previously, we made sure that we only work with numbers. Now let's say we actually name this combine, and it should work with both numbers and strings, because it turns out we can combine both numbers and strings with this plus operator. The only difference is that in one scenario we get back a number as a result, in the other scenario we get a concatenated string, as we actually already saw earlier in this module. But now I want to allow this behavior, because you could have an application where you want to have a flexible combination function that does work with numbers and strings. Therefore, I will also name this input 1 here and this input 2, and combine these two now. But we will have one problem, of course. Right now we set both parameters to be numbers. This means that we can call this function as long as we do want to work with numbers. Let's say down there we're creating a new constant, combined ages, and there I call combine and pass in 30 and 26 here as ages in whatever application we're building, and I thereafter console log combined ages, well, it shouldn't be too surprising that if we now compile this file here and we then reload this page, we get 56. So this works, we get this number. But of course, we have a problem if we try to create a string here. Combined names, for example. If I try to combine Max and Anna here, then, well, we immediately get an error here that Max is not assignable to type number because this, of course, is a string. Now, of course, we could change this to accept strings instead of numbers, but now the first function call would fail. And that is where union types can help us. If we have some place in our application, be that a parameter of a function or a constant or a variable we're using somewhere, where we accept two different kinds of values, well, then a union type can help us. To tell TypeScript that we are fine with either a number or a string, we use number and then the pipe symbol here, and then the other type we also accept. And you can have more than two types. You can accept as many types here as you need. So here I only need two though, and that's therefore the type assignment I'll go with, number or string. Now I get an error here that the plus operator cannot be applied to type string or number and string or number. That's actually not entirely correct. This should work because we can use the plus operator with both numbers and with strings, but TypeScript only sees that we have a union type here and it doesn't analyze what's in the union type. It just sees, okay, you're expecting multiple types. Maybe that includes types where I can't use the plus operator, hence I will complain here. Now, thankfully, we can work around that issue though. We can add our runtime type check here and see if input1, if the type of that is equal to number, and if the type of input2 is equal to number, and then move this calculation in there. Now just one improvement. Let's create result as a variable outside of that if check because of block scoping, so that this is a variable available in the entire function, and then just assign a new value in there. So now here we check if we do have two numbers. And therefore TypeScript knows that in here, input1 and input2 both will be numbers. Now let's add a else check here. And there we can set result equal to input1 dot toString, explicitly converting this to a string, and input2 to string. And this will then also be fine for TypeScript and JavaScript because we can concatenate two strings. So now we have almost the same calculation, but we make clear that here will always work with numbers, here will always work with strings, and then we return the result. And now with that, if we console log the combined names down there, and we compile this file, we'll see that once we revisit our page, we got the combined numbers there, which were simply added together, and hence we get a number as a result, and the combined names here. So this is how we can use union types to be more flexible regarding what we do in a function, for example, or anywhere else in our code. This extra runtime type check will not always be required when you work with union types, but often it will be because with union types you can be more flexible in, for example, the parameters you accept, but then you might have different logic in your function based on which exact type you are getting, so that your function is able to work with multiple types of values, but that it then does slightly different things depending on the type you're getting. So often you might need such a runtime check when working with union types, but you'll not always need it. You will certainly also encounter situations in TypeScript programs where you can use a union type without a runtime type check. It really depends on the logic you're writing. So now we got union types here. Let's build up on that idea of union types and also introduce literal types. Literal types are types where you don't just say that a certain variable or a parameter should hold, let's say, a number or a string, but where you are very clear about the exact value it should hold. We saw that early already, here in basics, const number 2, for example. There, if I hover over that, you see the type which was inferred is not number, it's 2.8. And TypeScript did infer this concrete number as a type here because it's a constant. It will never change, and therefore TypeScript knows the value I assign here is the exact type I have. So of course this is a number. You could say 2.8 is derived from the number type, but it's a specific number. And this does not just exist for numbers, but also for strings and so on. And especially for strings, it can be very useful. Let's say here in our combine function, we expect numbers or strings and we combine them differently based on what we get, but we also want to allow the caller of the function to define how the result should be returned so that we can basically force a conversion from number to string or the other way around. We could do this with a third parameter, and we could name that, let's say, result type or result conversion, or however you want to name it. And I want to describe this with a string, so I'll set this to type string. Now my idea is that I can call combine here with two numbers, and for example pass in a string of as number. And it's totally up to you which identifier you use here. Down there we might have as text, but then we might have another combination here, combined string ages, where I pass in two strings, but I still want to output this as number. And this would be a case where the third parameter can be helpful to force a conversion, because if I pass in two strings here, normally we would make it into this else branch and concatenate it. And I might want to return this as a number instead, so that I can also console log combined string ages here. So now we just have to take these identifiers into account in our function by including result conversion in our if checks. Now the question is, what exactly do we want to do? Do we want to make sure that we can force these two strings to be added as numbers? Or do we want to force the result, no matter if it was a mathematical calculation or a string concatenation, to be converted to a text or a number? If we want to force a conversion, we could add the if check here and check if result conversion is equal to as number. And if that's the case, I want to return result with a plus in front of it, which converts it to a number. The alternative would be parse float, for example. But here I'll just go for the plus, since this is a bit shorter. And else I want to return result to string to force an output as a string. So now we do the calculation based on the real type we get, but then we convert the result. That's one way of doing that. And if we save that and we then compile this file, we see this is the result I get. And we get that output, for example, for our string combination here, because, as I said, the combination itself, the calculation, so to say, is performed based on the type we feed in, which here is a string, so we concatenate it, and then we just convert the result. The alternative logic would be to check the type here and do a different operation based on the return type we're specifying here. So we could comment this out, and instead here say, if the type of input 1 is number and the type of input 2 is number, or if result conversion is equal to as number, then I want to combine values like this. And now to avoid this error, here I force the conversion to numbers by adding a plus in front of each input, so that each input is converted to a number and is guaranteed to be a number before I combine them. Side note, if you would pass in strings that can't be converted to a number, so something like max, for example, then you'll get NaN, not a number, as a result. Well, and in the else case, so that we don't have as number, or that we simply don't have number inputs, then we make it into this block here. And now with that, if I return result again here, and we then save this and recompile, we'll see a different output on our page. Now we get 56 in these two lines here, because now we're not converting the result, so we're not converting the concatenated string for this line, but instead we're doing the conversion before we combine the two values. So that's up to you which logic you want to implement. I actually want to have a closer look at the literal types concept, which I described at the beginning of this lecture. I'm passing in as number and as text, and the downside of this is that right now we as a developer have to memorize these values. We have to make sure that we don't mistype here. Now we could use an enum to improve that, but if we only have two values here, as text or as number, then maybe also such a literal type could be an option. We could say this shouldn't be any string, it should be as number or as text. So we use a union type combined with literal types. Literal types are the types which are based on your core types, string, number, and so on, but you then have a specific version of that type. So here we allow specifically these two strings, not any string, just these two strings. So we want a string for result conversion, but it has to be one of these two values. Any other string value will not be allowed. So that's the idea behind a literal type. And often you will use this in the context of a union type because you don't just want to allow one exact value. You could hard code it into your code if that would be the case, but you want to have two or more possible values. In this case, we got two possible values. So now we are guaranteed to get result conversion, which is either as number or as text. And for example here, if I now try to compare this to as num, because I have a typo here, TypeScript is able to tell me here in the IDE, and of course also if we save it and compile it here in the terminal, because it knows that as number without a R at the end will never be a valid value for a result conversion because I set this union type with these literal types. So now we again gain some extra type safety and ensure that we can't use this incorrectly. The same of course for passing in a value. If we have a typo here, we get an error. Only if we use either as number or as text, we're allowed to compile this. As you see, if I now compile this, this works and we get the same output as before here. So these are literal types, especially useful when used in conjunction with union types. Now, when working with union types, like this and this, it can be cumbersome to always repeat the union type. You might want to create a new type which in the end stores this union type. And you can do that with another cool TypeScript feature, the feature of type aliases. You create such an alias, typically before you use it, so here at the top of the file in this case here, with the type keyword. Now the type keyword is not built into JavaScript, it's supported in TypeScript though. And after type you add the name of your custom type or of your type alias, I should say. For example, combinable, but the name is really up to you. You can invent any name here which is not built into JavaScript or TypeScript as a key name. So something like date would not be allowed because that's built into JavaScript, but combinable is not built into JavaScript, not built into TypeScript, so we can use it. And now with the equal sign, you assign the type you want to encode in your alias, so to say. So we could store a number here, and now whenever we want to make sure that something should be a number, we could use combinable instead. Now, that doesn't make too much sense. It arguably would even make our code harder to read. If I use combinable down there, for example, this would work technically, but if we just glance over our code, it's not obvious that here we want a number or a string. Well, typically, therefore, you use that in conjunction with union types. So we can store a union type in our custom type, so to say, in our type alias, and now just refer to combinable down there instead of our union type. So we have exactly the same setup as before, we just have our reusable type alias here, which we can use instead. And that allows us to save some extra code and make sure we always refer to the same types or the same type setup when we use combinable. And of course, we cannot just use that for number and string, we can use that for any type setup we might want to store in an alias, including these two literal types, for example. So for these two types here, for this union type, we could also create a type alias, conversion descriptor, or however you want to name it, and store exactly this type in this type alias. And now we can use this type alias down there. So type aliases are really useful. You can encode more complex type definitions into your own types, into your own type names, so to say, and reuse that everywhere in your code where you need exactly this type setup, so that you avoid typos down there, and you can simply save code, write code quicker, and also be clearer about your intentions, for example, by choosing descriptive type alias names up there. Time for another new file. I'll rename app.ts here to union aliases ts and add a new app.ts file where we can start from scratch again, close the other file. And now in here, I want to dive a bit deeper into functions. Now, of course, we already worked with functions, for example, here in the union aliases file with the combine function. And for example, you saw that for functions, you can assign types to the parameters of functions. Well, turns out there's a bit more you can do with functions and types. For that, I'll recreate my add function, which simply accepts numbers, not strings, which does one simple thing. It returns n1 plus n2. So not too tricky. Now, as I mentioned, we can assign types to parameters. That's not new. The function overall, however, has one important other type. It has a return type. And here the return type is inferred by TypeScript. We can see it if we hover over add. Here at the end, the colon after the parameter list, this here describes the return type of the function. So the type of the returned value. Here I return the addition of n1 and n2, and since both these inputs are numbers, TypeScript is able to infer that the result of this will be a number, and since we return it, that the return type of this function therefore will be a number. If we would concatenate them as strings here, with toString for example, then TypeScript would correctly infer that we return a string here. Now, of course, we can also explicitly assign a return type here by adding a colon after the parameter list and then the type you want to return, like number. This would be the same type as inferred. If I, for example, set this to string, I would get an error here because obviously my calculation here does not match my described return type. Now, just as with variables, it's a good idea to let TypeScript do its job regarding type inference. And if you have no specific reason for explicitly setting the type, you should therefore not set the type and instead let TypeScript infer the type. Regarding the return types though, there is one interesting type which we haven't seen before and which might be brand new to you if you have no experience with other programming languages, because it is a type that doesn't really exist in JavaScript. It's the void type. Let's say we have the print result method. There we get a number argument, which should be a number. And in there, I want to console log num, and I want to console log it as part of a string where I say result plus num. So now this will be concatenated to one long string and will be output. And now I can call print result and, for example, pass to that the result of my add function call with 5 plus, let's say, 12. So I'm executing add here with two numbers, and the result of that, so what add returns, is then passed as an argument into print result, and that should print it to the console. If we now compile this and then have a look at that in our page or on our page here, we see result 17, which makes sense. Now the interesting thing here is the return type of print result. What would you guess is the return type here? So maybe you think it's string because I'm creating a string in here, but keep in mind we're not returning this. We're not returning anything here. And therefore this print result function here has a special return type, void. Now you might know this void return type from other programming languages. There you have something like this. JavaScript doesn't really know that or doesn't really have a name for this situation. TypeScript, however, does. So indeed, this function here has a return type of void. And of course, you don't need to specify it here. TypeScript's inference did its job. But I want to make it really clear that this has the void return type, which is why I am adding it here for demo purposes. Now, void really just means this function doesn't have a return statement. It doesn't return anything. It successfully completes, it does its job, it executes its code, it does not yield an error or anything like that, but it then does not return anything. That's the void return type. Now, technically in JavaScript, of course, if we would console log the result of print result here, and I now compile this and we see what gets output here on the page, we see that undefined is returned by that. So technically, and that's really interesting, in JavaScript, if we use the return value of a function that doesn't return anything, we get undefined as a value. And as you probably know, undefined in JavaScript is actually a real value. A value you, for example, also get if you try to access a property on an object which doesn't exist. So here we get void, even though technically this returns undefined. And now to make it even more confusing, undefined actually is a type in TypeScript. You can have undefined as a type, and for example, a brand new variable, some value, can receive undefined as a type, and you will not get an error. This variable will now just be forever undefined. How useful that might be is a different question, but undefined is a valid type in TypeScript. Nonetheless, here you see we're getting an error. And we are getting an error because a function is not allowed to return undefined. Technically, it of course does, but TypeScript thinks about functions a bit differently. You should use void here if a function returns nothing and not undefined, because with void you make clear that this function deliberately does not have a return statement. If you would say undefined here, then TypeScript would expect that you have a return statement where you just don't return a value. That's the technical difference. Now you see I'm not getting an error. From a JavaScript perspective, this is basically the same as this, but TypeScript makes a differentiation here, and therefore void is the type you want to use if you don't have a return statement. Undefined, which you will rarely need to be honest, can be used if you return without returning an actual value. But again, this is a rare use case, and you could use void with a return statement like this as well. You would not get an error, and by default you would actually also use void in this scenario, unless you really have a function that should produce undefined and you want to be clear about that. But again, that will rarely be the case. I just want to make sure here that you understand the difference between void and undefined, that void is the standard which you'll use in pretty much all scenarios where you have a function that does not return a value, and that you can assign it explicitly, but of course TypeScript also is able to infer it, like it would be able here as well. I just added this for demo purposes here. So you can use types for function parameters and for the return value of the function. Now, to take it to the next level, what if there also were a function type itself? Now let me make it clear what I mean. Let's say we have a variable, combine values, and this variable by default has a type of any. Now, as you learned, any is not that useful. What I want to do eventually is I want to set combine values equal to add. So I want to store the add function, a pointer at this add function, in combine values, so that in the end we can console log combine values and execute combine values as a function to which I pass 8 and 8. Now if I save that and I execute this after compiling it, so if we compile this file and then we let this reload, we get 16 here. So that works, and we would expect it to work because that is normal JavaScript code. We can store a pointer at a function in another variable and then therefore execute this variable as a function because, well, it points at that function, right? So we can execute that function through that variable. The problem we have with this snippet here from a TypeScript perspective just is that combine values is any. So if I set combine values to a number here thereafter, of course, we can compile this, unfortunately, because TypeScript has no chance of detecting that this is unwanted or that this could cause a problem. But at runtime, we would get an error, because obviously we try to execute combine values as a function when it actually is a number. Now we want to avoid this, and for that we need to be clear that combine values will hold a function. Now a first step into that direction is that we set the type here to function. Function is a type provided by TypeScript in the end, and this makes it clear that whatever we store in here has to be a function. Therefore, here I'm getting an error because 5 is a number and not a function. And if I comment this out, we can compile this. Otherwise, we would get an error during compilation. And now this again runs as expected. So that's good, but it's not perfect because now we say this should be a function, but it could also set combine values equal to print result, for example, here. And of course, TypeScript would not complain because print result is a function. But of course, it's not a function that takes 2 arguments. So again, if I compile this, TypeScript will not complain. But if we reload, we see undefined here and result 8. So I don't get the result I want because I stored the wrong function in there. Again, it would be nice if TypeScript would tell us about that. TypeScript can't inform us about this because all we said to TypeScript is that we want to store a function in there, and this is clearly the case. So it would be good if we could be more precise regarding how the function should look like that we want to store in combined values. And that's where function types come into play. Function types are types that describe a function regarding the parameters and the return value of that function. A function type is created with this arrow function notation you know from JavaScript, or at least close to that notation. You don't add curly braces here because we aren't creating an arrow function here. We're creating a function type instead. Now on the right side of this arrow, you specify the return type of the function you eventually want to be able to store in here. And that should be number. Now with that we're saying combined values accepts any function that takes no parameters and then returns a number. Now that's of course not entirely what we want. We want to make sure that combined values takes a function or is able to store functions that take 2 numbers and return a number. Now for that we can add parameters here to this function type. We don't have to match the parameters names from up there, just the types. So we could have A, which should be of type number, and B, which should be of type number. And now what we're saying to TypeScript is that combined values should accept any function that takes 2 parameters, where each parameter is a number and where the function overall then returns a number. And that's why TypeScript does not complain about us storing add in combined values, because add is a function that perfectly satisfies this type definition. But it does complain about print result, because print result, as it tells us here, is a function of type 1 argument, which is a number, nothing is returned, whereas we actually expect to get a function with 2 arguments, where each argument is a number, and we also return a number. So we have a mismatch here, and if I would try to compile this, we therefore would get an error here, of course, in the compiler, and we only can fix this by removing this line of code. Now we are able to recompile this without errors, and now this runs as expected. So function types allow us to describe which type of function specifically we want to use somewhere, be that an expected value in a parameter, if we create a function with some callback, or like here, a variable. Now speaking of callbacks and function types, there it works pretty much in the same way. Let's say we have a new function up there, add and handle, let's say, and there we expect to get 2 numbers. And then I also want to get a callback function here, so a function which is passed in as an argument that should do something with the result. Then here we could generate the result, of course, but now I'm not returning it, but instead I want to call the callback function and pass in result. Now for that I want to be really clear that callback should be a function. So again, I'm using that function type definition that maybe does not return anything, but that does take a number as an argument because we're passing in a number here. So the callback function, the function we're passing into this function as a parameter, should accept a number. And now down there we could call add and handle, pass in 10 and 20, and then pass in a function, for example, an anonymous function here. So now here, when we call the function, this is of course not a function type, but a concrete value we're passing in for this third argument. So this now here is an anonymous function I'm creating here. And there we know we'll get a number, maybe name it result here, and then we can do with it whatever we want. And now if we compile this, we see this log down there, 30, which is the result of our callback function, which we pass to add and handle, where add and handle combines the two numbers and then calls the callback, where the callback has to meet this condition here. The advantage of us defining the callback function definition here is that inside of the function we pass in as a callback, TypeScript is able to infer that result will be a number, and hence we could do anything with result here, what we could do with a number, without explicitly stating the type here. Because TypeScript knows result will be a number, because we made it really clear that the callback will get one argument, which is a number. Hence, also if we would expect a second argument here in the callback, we'd get an error, because we know, well, the callback we expect in our add and handle function only should have one argument. So if we then pass in a callback function which takes a second argument, that clearly is a mistake. The only thing TypeScript does not pick up is if we return something here. If I return result, then the callback does return something, even though we made it clear that it shouldn't return anything. This, however, is not a mistake or a bug in TypeScript, it actually happens on purpose. By specifying void here on our callback type, we're essentially saying we'll ignore any result you might be returning here. So we're basically saying in add and handle, where we get that callback function, we'll not do anything with the return type. That's why you'll be able to return something here without punishment, but you know, because it's clearly defined here on the callback type, that the callback will not do anything with the value you might return here. So that add and handle inside of the function will not do anything with that value you might be returning. And that's of course a useful piece of information. You might expect that in here we're doing something with the value returned by the callback. And by specifying this type here, we make it really clear that inside of add and handle, we're not interested in any return value. So this does not force you to pass in a callback that does not return anything. It just tells you that anything you might return will not be used. For the parameters, it's of course different. There, this is enforced, because here it really matters that you know if you're passing a callback that expects more parameters, well, then you'll get an error or you'll not get the result you want because I only give you one result. So there we can't just ignore what you might want, as it's the case for the return type. We can ignore that here. For passing something in, the add and handle function is responsible for that because that's where the callback gets called. This is why parameters are enforced, and TypeScript is really strict regarding the number and type of parameters of callback functions, and why it doesn't really care about the return type. We're almost done with the basics about TypeScript and the core types. There are two more types which are good to be aware of because they will matter from time to time. And the first type is the unknown type. For that, I'll name this file here functions.ts and add a new app.ts file. And in there, let's say we have a new variable, user input, and this is of type unknown. It's not of type any, which would be the default, but unknown, which is a different type introduced by TypeScript. It might be unknown because we don't know yet what the user will eventually enter. If it's a number, if it's a string, we don't know. Now, the interesting thing about the unknown type is we can store any value in there without getting errors. So this is all allowed. If I now compile my file here, you see I get no compilation error. So thus far, it's the same as if we wouldn't have assigned a type here, and hence we have the any type, or if we would have explicitly set any as a type. But still, unknown is different to any. This here works, but we'll run into issues if I have another variable, let's say username, which should be a string, and that's uninitialized here, but then here I want to set username equal to user input. Now you see we're getting an error that type unknown is not assignable to type string. So username wants a string, and of course unknown is not guaranteed to be a string. Here I assigned one, but that's just the case in this line. User input technically could hold any value because it's unknown. Now the interesting thing is if I switch unknown to any, this error goes away because any is the most flexible type in TypeScript, and it basically disables all type checking, and TypeScript just says, I give up, do whatever you want. Unknown is a bit more restrictive than any. With unknown, we have to first of all check the type that's currently stored in user input before we can assign it to, for example, a variable that wants a string. So since a string is wanted here, we could check if type of user input is equal to string, and TypeScript will detect this check and understand that in here, what I store in username, because it's inside of this if statement where I check for a user input being of type string, user input is guaranteed to be a string, and therefore I can safely assign it to username. So I need such an extra type check here with unknown to be able to assign an unknown value to a value with a fixed type. And therefore, unknown is the better choice over any if you know I can't tell exactly what type I'll store in there. It might be a number, it might be a string, but I know what I want to do with it eventually. Well, just add an extra check to make sure that what you want to do can be done, so that if you want to work with a string, you have a string and you're good. And then unknown is better than any because it makes sure that you're not allowed to do everything, but you have at least some type checking. Of course, if you have a chance of knowing in advance that user input is always a string or a number, well, then you should use string or such a union type instead of unknown. So unknown still is a type you shouldn't use all the time, but it is better than any for the reasons described. The last interesting type I want to show in this module is the never type. Now we saw a function that returned void, so that never returns anything. Never is another type functions can return. And that might sound strange. Let's have a look at how it works. Let's say we have a function generate error. Here I expect to get a message, which is a string, and maybe some error code, which might be a number. Now inside of this function, let's say, we throw an error. So this should essentially be a utility function that generates error objects and throws them. So here we might throw an object, which we can do in JavaScript. We can throw any object or any value as an error. And that should have a message property in which I store the value of my message argument here. And I want to have an error code property, let's say, where I store the code argument in. So now this would be a valid function, and we can call this with an error occurred, for example, and a code of 500. If we do that and we compile this file here, we see that once this reloads, we get our error, well, as an error here. And this might sound pretty abstract, but actually it isn't. Having utility functions like this would be pretty standard in bigger applications where you don't manually want to throw an error in 10 different places of your app, but where you want to reach out to one convenient function that builds the error object for you and maybe also throws it immediately, so that you can call this function with different inputs, but you always have an error being thrown. Now the interesting thing about this function is it does not just return void. I actually can specify that it returns void, because of course it returns nothing, but actually it does not just return nothing. If we're totally honest, this function returns never. This function never produces a return value. If I would try to store the return value here, and I console log result, and I then compile my code and this executes, we see there is no undefined being logged here, because since an error is thrown, this essentially crashes our script, you could say. It cancels our script. And this will always be the case for this function. Of course, we can wrap it in try catch so that we can still continue in the script, but this function essentially never produces a value. This function always crashes the script or this part of the script if you're using try catch, and therefore never returns anything. And hence the return type of this function actually is not just void, but also never. Now the interesting thing is, if you hover over it without assigning never, you see the inferred type is void. Also because never is a newer type. It's been around for some time now, but it wasn't built into the first versions of TypeScript. And therefore, void is typically assumed, and it's not horrible to leave it at that. But you can be very clear and explicitly set never as the return type to make it really clear that this never returns anything. So from a code quality perspective, this might be clearer regarding your intentions and make it really clear to other developers reading your code that this function is intended to never return anything and to essentially crash or break your script or that part of the script. Another function that would never return, by the way, would be a function with an infinite loop. So if we have while true in there, that creates an infinite loop, and that therefore also would be a function that never returns. The error function here, or the function that generates and throws an error, probably is the more common use case though. So never, also an interesting type which you can use on functions for cases like this one here. Now with that, we had a thorough look at all the core types and the TypeScript basics. You hopefully now understand how we create and assign types, how we assign types to variables and to parameters and why we do that, how type assignments in TypeScript differ from JavaScript type checks, that JavaScript uses runtime types and TypeScript uses static types that matter during development, that the built JavaScript code therefore does not include any type assignments. It of course includes any type checks because that is regular JavaScript code, but something like this here, this is simply not allowed in JavaScript. This is not supported syntax. That's TypeScript only. So that's hopefully clear. And then we had a look at numbers, strings, booleans, at function types and setting return types, argument types, and also describing the type of an overall function, which can be helpful if you want to have a variable that eventually holds a function. We had a look at objects and arrays and enums and how that can be interesting and help you. The same is true for tuples. And now we also had a look at aliases, type aliases, where you can merge complex types into aliases which you can reuse. We had a look at literal types and union types, which can be useful for scenarios where you expect more than one possible type. And now at the end, we also had a look at unknown and never, which are niche types, but still in their niche, they can be very useful. And now with these basics, we'll dive deeper into individual aspects and of course also explore other types and JavaScript constructs where TypeScript can be helpful. In this module, we'll take a closer look at the TypeScript compiler. Thus far, we always just used it by running tsc and then pointing at a file which we want to compile. Now, whilst that of course works, it's not really feasible for bigger projects where you have multiple files or where you simply don't want to run this command after every change you want to see in practice. In addition to that convenience, which we currently don't have, there also are a couple of interesting things you can configure regarding the compilation process, which actually change what is compiled and how it is compiled. And these are therefore the things we'll take a closer look at in this module. Now to get started, I want to make sure that I don't have to rerun this command here, this tsc command where I point at a file after every change I make. Because right now, whenever I change something here in my TypeScript file and I want to reflect that in my output file and on this web page here, we have to save the file, run the compilation again, and then reload this file, or if we have our npm start process running, which we should have, then at least our browser will automatically reload if we don't directly open the file, but instead are on localhost 3000. But nonetheless, even though with that reloading automatically, we still have to manually rerun the compilation command. So to get rid of that, we can enter watch mode. And that means we can tell TypeScript to watch a file, and whenever that file changes, TypeScript will recompile. So for that, we can still run the same command, but now we add --watch at the end, or just --w. If we do that, then we are in watch mode on that file. And now whenever we change anything in there and we save that so that the file on the disk technically changes as well, you see this automatically recompiles. And of course, this also means that if we would do anything which is not allowed, like for example, reassigning to a constant and then a wrong type as well, whenever we try to do that, of course, it also recompiles, but then just as if we manually run the command, we see the compilation error down there. So watch mode is already a big improvement. The downside is that we still have to specifically target this file here. And at the moment, of course, this is the only file we're working with, but typically in bigger projects, that's not necessarily the case. So as I mentioned in the last lecture, watch mode is a great start, but what if we have more than one TypeScript file? What if we also have an analytics.ts file where we hypothetically send analytics data to our server? Now here, to just have anything in there, I'll just put in a console log statement, but of course you could be sending HTTP requests to your analytics service here, as I said. So let's say we also did import this file here in our index.html file. If we point at analytics.js here, which does not exist yet, but which will exist after compilation, then we could be loading these two files, and of course we want to compile both files whenever one of them changes. Now for that, it would be nice if we could enter some general watch mode where we just run tsc like this, so without pointing at a file, and it just watches our entire project folder and recompiles any TypeScript file that might change. Well, turns out that this is possible. For that, we just need to tell TypeScript that this here is one project that should be managed with TypeScript. And we do that by, first of all, and we only need to do this once, running tsc --init. So I'm not pointing at a specific file here. I just run tsc and then --init here. And again, this is only required once. It will initialize this project in which you run this command as a TypeScript project. That means it will now basically tell TypeScript that everything in the folder where you run this command, and therefore it's important that you navigate it into the right folder before you ran this command. With the built-in terminal here in VS Code, I'm automatically in this project folder where my files are, so that this project is now managed by TypeScript. So let's hit enter, and what this does is it creates this tsconfig.json file. This basically is the indicator for TypeScript that the project in which this file lies and all subfolders of this folder should be managed by TypeScript. Now, if we have a look into this file, we see there are a bunch of options, most of them commented out. They're just there so that you see that you could set them, and you got a short explanation here as well. But we don't have to worry about those right now. We'll dive into them in a second. For the moment, let's just close this file here. And let's see what this gives us. Because what it does give us is that we can now run just tsc like this without pointing at a specific file. And what this will do is it will tell TypeScript to go ahead and compile all TypeScript files, so all .ts files, it can find in this project. So if I hit enter here, you see this takes a while. And now what we got is this analytics.js file and this app.js file. Now, the analytics.js file was just created by TypeScript because it found that we have the analytics.ts file, and as I said, it will now compile all TypeScript files in the project. And of course, this can also be combined with watch mode. You can run tsc-w or --watch as I showed before, and this will now enter watch mode for all TypeScript files. So now, whenever I change one of them and I save it, it will recompile. And it will recompile that file that changed and therefore also reflect the change in the JavaScript file. And hence now here, if I go back to my page, we see sending data here as well, because now the analytics.ts file was also compiled. So this is now how we can manage multiple files with TypeScript. Now, one word about having multiple files. When you work with multiple files, as we're doing it here, you can also import them into each other with modules, which you might know from vanilla JavaScript. There we have modules as well. It is something I'll cover in a dedicated section of this course though. So for now, we just have two files which are not imported into each other, but which are instead imported into index.html. Now with that out of the way though, we know that we can manage this as a project and that we can compile multiple files here. Now let's have a look at the tsconfig.json file, because this is a crucial file for managing this project. It essentially tells TypeScript how it should compile these files. Now, before we dive into the compiler options, where we, as the name suggests, can configure how the compiler behaves, let's scroll down to the place before the closing curly brace, but after this nested closing curly brace. And let's see some of the options we can add here which don't affect the compiler or the compilation step behavior, but instead how the compiler works with this project. Because there, for example, you can set a exclude option. Now, if you add exclude here, that will be an array. And what you can enter here are paths to files which should not be included in compilation when you run TSC on the entire project. So for example, here we could say we want to exclude analytics.ts from compilation. Now, of course, this doesn't make much sense here, but just to show how this works. If we do that, and we now rerun TSC, and I first of all delete analytics.js so that we can see if it is recreated. If we now run TSC or TSC in watch mode, you see no analytics.js file is created. And the reason for that is that we're excluding that file. Now, of course, for this file, this doesn't make a lot of sense because I typically want to include it. But if you had a file that for some reason shouldn't be compiled, you can exclude it like this. You can also work with wildcards. And for example, if you had a file that's named analytics.dev.ts and you don't really want to compile that, you could say all files that end with dev.ts should not be compiled. And you can do that by also adding an asterisk here, which is a wildcard basically. And now TypeScript will ignore any files that have .dev.ts included. You could also add asterisk slash here, and that would mean any file with that pattern in any folder will be ignored. So these are things you can set up here. The only thing I want to set up here, and that is a setting you will often find, is that I want to exclude node modules. And the idea here is that I don't want to compile any TypeScript files I might have inside of node modules. Now, node modules is that folder that holds all the dependencies we install here in package.json and the dependencies of these dependencies. And therefore, these are third-party libraries we're importing, which we don't want to touch. And if any of these libraries should ship some TypeScript code, then we certainly don't want to compile it. It will just slow down our compilation process, and in the worst case, it might even break our project. So therefore, it's quite common to exclude node modules here, though I will say, if you don't specify the exclude option at all, node modules is automatically excluded as a default setting. So you don't really need to add this option here. This would be the default. I just want to show that exclude exists and how you could use it. If the only thing you want to exclude is node modules, you don't have to add the exclude key at all. If you do add it though, you should set node modules because otherwise it will not exclude that. Now besides exclude, we also have include, and include allows you to do the opposite. It allows you to specifically tell TypeScript which files you want to include in the compilation process. And anything that's not listed here will not be compiled. So if I point at app.ts here, you'll see if I rerun TSC, we also will get no analytics.ts file, or no analytics.js file, I should say. Why? Because analytics.js is not included in include, and as I said, if we do set the include key, then we really have to include everything we want to compile. So of course here, we could then also add analytics.ts here, and with that addition, we would start and compile it. As you see now, we have the analytics.js file. Or as an alternative, we specify a whole folder here, which typically holds the files we want to compile. Exclude, by the way, if set alongst include, will filter down include. So if we exclude some subfolder of a folder that is part of include, then that excluded subfolder will be excluded. So basically we compile include minus exclude. Now, of course, here I don't want to set include. I want to compile all TypeScript files, and therefore I don't have to worry about that. Excluding node modules is all I need, and as I explained, theoretically I don't even need to add that because that would be excluded by default. Now you also have a files option. This allows you to point at individual files. So it's a bit like include, with the difference that here you can't specify whole folders which you want to include. Instead, you really just specify the individual files you want to compile. That might be an option for smaller projects where you know you will only work with 3 files. And for some reason, you got a couple of other TypeScript files which you don't want to touch though. Then you can set a list of files like this. In reality, you might not need that setting that often though. And therefore, that's it with the basic compilation or project management options here. Now, of course, there is way more we can specify though. Way more we can specify about the compiler itself and how it behaves during the compilation step. So now that we have an understanding of how we can manage our files with the compiler, let's dive into the compiler options, because that's really interesting. This allows us to control how our TypeScript code is compiled. So not only which files, but also how the files which are getting compiled are treated by TypeScript. And there you see we have a bunch of options. Now you got short explanations next to these options. Some explanations arguably are a bit cryptic, others are quite clear. And I will say that a lot of these options, most of these options, will not matter in most projects. So you'll not set all of these options, not even close. You typically can ignore a lot of these options. Now I will pick up on the important options here throughout this course, because some options only make sense when we learn about a certain feature. And I want to dive into some options right now already though. And for that, let's go through that file from top to bottom and see what we got there. And let's start with the target option. As you see, this actually is set by default. It's not commented out. And what you do with this option is you tell TypeScript for which target JavaScript version you want to compile the code. Because what TypeScript does is it does not just compile new features like the type annotations that don't exist in JavaScript to JavaScript code. So it does not just take care that this here works. It also compiles the code to JavaScript that runs in a certain set of browsers. And you basically define which browsers support the compiled code by setting the target. The default target here in this project, as you see, the initial target which is getting set up is ES5, which means all TypeScript code is compiled down. And we can actually see that. If I run tsc here to compile all my files, we see in app.ts I'm using let and const, but in app.js we see var. And that happens because we got a target of ES5, and in ES5 world we don't have let and const. So the good thing here is that we can use TypeScript to generate code that works in older browsers as well. But it's totally up to us if we want to do that. Maybe we don't want to do that with TypeScript because maybe we got some other build tool that will then take care about the JavaScript transpilation, and therefore we don't want to have TypeScript do that. Or maybe we want to ship code that only works in modern browsers because we know our app only will run in modern browsers. And therefore, alternative options can be seen here if you delete the value, and then here in VS Code at least, if you hit Control Space to get the auto-completion, you see a bunch of suggestions and you see all available values here. Now over time, this of course will change because we got new JavaScript versions released. You saw we set this to ES5 before. If you don't specify target at all, then right now TypeScript compiles to ES3 even, so it supports an even older version. But you can also go with ES6, which is more modern, which for example supports constant let, or take an even more recent version. ES6 is the equivalent to ES 2015, just for the record. So if we set this to ES6, for example, and I rerun the tsc command after changing the tsconfig.json file, you will see that now in app.js we got let and const, because now that is supported there. So that is up to you. Of course, the more modern of a JavaScript version you pick here, the more concise your generated code is, because TypeScript has to compile less and less code, or it has to work around non-existing features in less situations, and therefore the compiled code typically is then more concise and shorter. So that's the target. What about the other options? We also got module here. Now, module is an option I'll skip for now because it really only makes sense once we learn about modules in TypeScript and how we can connect multiple files. So let's ignore that for now. Lib is an interesting one though. Lib is an option that allows you to specify which default objects and features TypeScript knows. With that, I mean things like working with the DOM. Let's say in index.html, we have a button. And on this button, we say, click me. And when we click this button, we just want to print the message. Now in app.ts, we can select this button. We can get access to this button with document, query selector, for example, selecting the first button we find. Now, if we do that, then this works. We get no TypeScript error here. So if I go to my button and I add an event listener here, I get an error here actually because TypeScript doesn't know for sure whether we find a button here. For now, we can work around that with an exclamation mark after this line, and I'll come back to what exactly this does in the future. It basically tells TypeScript, don't worry, such a button will exist. We will get a value here. So now we can add a click event here and then define some anonymous function maybe where I console log clicked. Now, the interesting thing here is not so much that I had to add the exclamation mark. As I said, I will come back to that. But that if I run TSC, this just compiles. Now, shouldn't TypeScript complain that document is unknown to it? How does it know that we have such a document constant or variable available? How does it know that even if we have that available, that it holds an object which has a query selector method? How does it know that button is something which has an add event listener method? How does TypeScript know all of that? Now you might say, of course it knows, because in vanilla JavaScript this would be valid code. But keep in mind that when you write TypeScript code, you don't necessarily write it for the browser. You could be writing your Node.js application with TypeScript, and there indeed this would all not work. So the reason why this works is this lib option. And as you see, it's not even set here, but if it isn't set, then some defaults are assumed. If it's not set, the defaults depend on your JavaScript target here, and for ES6, it by default includes all the features that are globally available in ES6. For example, the map object, which is available in ES6. Therefore, it wouldn't complain if you use map. So it assumes all these ES6 features which are made available globally in JavaScript, that they are available in TypeScript as well. And in addition, it assumes that all DOM APIs are available. You find the detailed descriptions about all these options, by the way, in the official docs, which are linked in the lecture at the end of this module. So long story short, if the lib option is not set, some defaults are assumed, and these are typically the defaults you need to have TypeScript run in the browser. So all the DOM APIs and so on. If we comment this in, and I now compile everything, I therefore get an error, because now by commenting it in, we don't have the default settings anymore. Instead, we now say, hey, please include some default libraries, so some default type definitions, you could say, which I will give you in this array. And as you see, I'm not passing any description, any paths, any values here. And therefore, what I'm saying to TypeScript now is, hey, regarding all the defaults you know, please take this into account, and you know nothing. So only if that's commented out it works, because then TypeScript will assume some defaults. If I set the defaults explicitly, well then TypeScript of course adheres to what I'm setting here. And hence here, for example, it doesn't know document, it doesn't even know the console here. So therefore, we want to set this to more reasonable values. And again, if you hit Control Space in here, you get auto-completion. And for example, there we could add DOM. That's an identifier, and there are some predefined identifiers which TypeScript understands. Again, you find a complete list in the official docs. The docs for this option are attached to this lecture as well. So this is an identifier TypeScript understands, and it's an identifier which basically unlocks all the DOM APIs in TypeScript so that TypeScript understands what you're doing there. So now already you see it knows console, it knows document, and so on. So now since we're working with next-gen JavaScript, we should also add the ES6 option so that TypeScript also understands all globally available ES6 options. And it's also a good idea to add DOM iterable and script host. With that here, we would unlock all the core JavaScript features you would want to work. And this, by the way, is the exact default setup you get when you set target to ES6 anyways. So if you comment this in and set it up like this, you have exactly the same behavior as if you don't specify lib at all. Now here I will comment it in though, and with that, this will compile. Again, setting this is a bit redundant though, just want to explain what it does. Now, also interesting is allow.js. With allow.js, and by the way, also with check.js, you can also include JavaScript files in the compilation. Now, with allow.js, a JavaScript file will be compiled by TypeScript. So even if it doesn't end with .ts, TypeScript will compile it. With check.js, it will not compile it, but it will still check the syntax in there and report potential errors. This could be nice if you don't really want to use TypeScript, but you want to take advantage of some of its features. And as far as TypeScript can help you with the AnyType only, which is effectively what you have in JavaScript, it will do so if you enable these options. Now, we don't need it for this project, and for this project, we would want to make sure we don't double compile these JavaScript files, which do stem from TypeScript files. So we would have to tweak the include and exclude settings a bit. But you could use that in projects where you don't want to use TypeScript at all, or where, for whatever reason, you have some vanilla JavaScript files next to your TypeScript files, and you want to check the vanilla JavaScript files as well. Now, let's fast forward a bit. JSX is an option that can help you with React.js, which does not really matter for us here. Declaration and declaration map is also not important here. DTS files are an advanced concept which matter to you if you're shipping your project as a library to other people, and you need basically a manifest file which describes all the types you have in your project. That's such a DTS file. Source map is an interesting one though. Source map helps us with debugging and development. So to show what this does, let me compile everything without that source map setting. If we now go to the browser and we want to understand what our code does, we can go to the Sources tab here in the Developer Tools, and there we find our JavaScript files. Now we can dive into these files, and the good thing is these files are fairly readable to us humans, of course, because they contain JavaScript code in the end. Now that's good, but what if we had more complex TypeScript code and we want to debug our TypeScript code and not the compiled JavaScript code? In other words, it would be nice if we would see the TypeScript files here and not the JavaScript files. With the source map option, you can get there. If you set this to true and you run the tsc command again, then you see we got these .js.map files being generated as well. Now, if we look at them, they're pretty strange files, but what they do is they basically act as a bridge, which is understood by modern browsers and the developer tools there, to connect the JavaScript files to the input files. So with these files generated, if I reload here, you see in the Sources tab, we now not just have our JavaScript files, we also see our TypeScript files there. And we can even place breakpoints in the TypeScript files. And if I now click on that button, for example, it pauses in the TypeScript file, which is, of course, super, super convenient, because that really takes our debugging process to the next level, because we can work directly in our input files, basically, in our TypeScript files, instead of the JavaScript files. Now, nonetheless, here I'll comment this out, because we have a fairly simple project here, and I don't want to have these extra .map files lie around here. But this is super useful in projects because it simplifies debugging. Let's move on. We got the out file option here. Now, this option does not matter to us right now. It won't work right now. More interesting to us is outdir and rootdir. The bigger your project gets, the more you might want to organize your files. Typically, you don't just want to have your files lie around here in your root level project folder. Instead, what you often will see in projects is that you have a source folder and you have a dist folder next to next. So the dist folder has the job of holding all the output, so all the JavaScript files, let's say, and the source folder might hold all our TypeScript files. So we can move the TypeScript files into the source folder. And if I now delete the JavaScript folder, we have the problem that if we compile everything, these TypeScript files are compiled because TypeScript, the compiler, does look into subfolders, but the output sits next to our input files. And that's something we can control with the outdir, for example. If we set outdir, we can tell the TypeScript compiler where the created files should be stored. We could set this to dist. Now, if we do that, then if you run TSC, you will see that the JavaScript files indeed are not placed in the source folder, but in the dist folder. Now we just have to adjust our index.html file and there point at dist app.js and dist analytics.js, or alternatively move the index.html file into the dist folder, but then our dev server wouldn't work correctly anymore right now. So let's just adjust these imports. And with that, we got a working application still, as you see, but now with a cleaner project structure. Now, the good thing is, if we had a subfolder here, an analytics folder, let's say, and we had our TypeScript file in there, then if we recompile, and it does not matter if you do it with this command or in the watch mode, this folder structure you have in the source folder will also be replicated in the dist folder, which is of course very convenient because that makes sure that you can import the files basically as you would import them in the source folder as well, so that the structure you set up there is kept. Now you can also set the root directory and set this specifically at the folder where your files are stored in, like in this example source, to make sure that the TypeScript compiler does not look in other folders. That's also something you could do with the include option down there, right? But with root directory, the TypeScript compiler will not just look only at that source folder, it also makes sure that the project structure you set up there is kept in the dist folder. Now, it did so by default before, as you saw, but keep in mind that before, it would have included any TypeScript files here, also outside of source. So, for example, if we comment this out temporarily, if we had a user folder here on the top level with a user TS file, where we have a username of Max, let's say, then if we compile this, you will also see that user folder in the dist folder. And now the source folder is included as well, because now we have a TypeScript file on a higher level, and therefore the TypeScript compiler thinks that our whole project again is the input, and it replicates the folder structure it finds there in the dist folder. Now that's of course not what we would want, and that's where the Rootdir option helps us. Now if we set this to source, even if we had other folders with TypeScript files in there on the root level, they would not be included in the output, and the source folder itself would not suddenly end up there. So often you set both rootdir and outdir to be really clear regarding where your input files live and where your output files should be generated in. If we move on, we can ignore composite. We can have a look at remove comments. Should be pretty clear. If you set this, then any comments you might have in your TypeScript files will be removed in the compiled JavaScript files. So if I comment this in and I compile my code, you see in app.ts I have a comment, in app.js it's not there. So you can do that to make your files smaller, and therefore this might be a nice option. You can also set noemit if you don't want to generate any JavaScript files. Now this might sound strange because that's the idea of TypeScript, but if you just want to check whether your files are correct, but you don't want to write all these output files, to save some time, for example, in a bigger project, then you could set this to true to just have the TypeScript compiler check your files and report any potential errors without actually creating an output file. Import helpers is not really important to us here, we can ignore that. Down-level iteration is an advanced option. It is interesting when you compile your code to older versions of JavaScript and you work with for loops, then in some rare scenarios you could run into issues where the compilation doesn't work correctly. This option, if you turn it on, gives you a more exact compilation, which will work in these niche cases. So therefore you might think you should always turn it on, but it will also output more verbose code. So you should only turn this on if you have loops and you see that your generated code suddenly behaves differently than it should regarding those loops. We can ignore isolated modules, but there is one other option, which is actually not even mentioned here, which I still want to mention myself though. And that's the noemit on error option. You can set this to true or false, and the default is false. Now what does this do? If we set it to false, let me show you where this might be a problem. It is a problem if we introduce an error, or it can be a problem. Let's say here, I do have my button and I remove this exclamation mark. Now, even though we don't fully understand what's going on, the problem here simply is that TypeScript does not know that we certainly have a button here. After all, when querying for a button, we might not get one. If there is no element in the DOM that's satisfying this selector, then this will return null. And that's basically what TypeScript complains about. Here we access something on a potential null object, and that's not good. Now, that's an error we have here. If we compile our code, we also get this error here in the console. Nonetheless, the file is created. So even if I delete the app.js file, it will be recreated. So even if we have an error, TypeScript creates a JavaScript file. This might or might not be wanted. Maybe you have an error in your TypeScript file and you don't really know how to work around it, but you know it will not be a problem in the final app. Like here, even if we don't know about the exclamation mark, well, if we don't know about the exclamation mark, we might not know how to disable this error, basically, but still we know that this will work in our page here. So we might be fine with compiling this despite having an error. But of course, in reality, you should aim for error-free projects and rather learn how you can work around this issue than ignore it. Nonetheless, you could set this to false or not set it at all because false is the default if you are fine with generating JavaScript files if you have an error. If you set this to true, however, what will happen is that problematic files will not be generated. If I now rerun this, you see, nothing is generated actually. Even the analytics.ts file is not output there. If we have some content in there, besides console log, you see, it's not getting generated. And the reason for that is that we have an error in a file. And if any file fails to compile, no files will be emitted. So here, therefore, we have to make sure we fix this error before we then can get TypeScript to again compile files for us. And therefore, it is an option I typically like to set because I'm not interested in getting JavaScript files if I still have errors in my TypeScript files. So that was an important first set of options. Now let's dive into these strict options because these are pretty interesting. There is this strict true option, and actually what this does is it enables all strict type checking options. So effectively setting this is the same as if you would set all these options separately. So you can either set all these options one by one or just set this option. Of course, you want to set the individual options if you want to have some options set to false, because otherwise they're all set to true. If you want them all set to true, then using just this option is of course way shorter. Now, what do these options do though? Let's start with no implicit any. No implicit any is a quite interesting option that helps us write better code. Let's go to our analytics file here, and there let's add a function send analytics that gets a data option, let's say. And there we could send this to a server, but here I'm just console logging it. Then I call send analytics with the data, so with the string. Now, as you see, my IDE already complains here, and so does TypeScript, the compiler, because the two, of course, are connected if I try to compile this. Parameter data implicitly has an any type. So this seems to be related to this no implicit any option. Indeed, if I set this to false, so if I set all strict options to true, but I set this option to false, which I can do, then this error goes away, both in the IDE and when we compile the code. So what does this option do? It ensures, and I'll comment it out again to turn it on again because of strict true, it ensures that we have to be clear about our parameters, about the values we're working with in our code. Here, we don't give TypeScript any information about the type of data we'll get as a parameter here, and we should. If TypeScript is able to infer this, then of course it's fine, but here, how would TypeScript be able to infer it? From this line? Well, keep in mind that this function gets declared first before this file executes. So at the point of time when the function is created, there is no chance of knowing what will end up in there. So here we can fix this error by simply declaring the type and being clear about which type we use there. Now please note that if you had a variable logged and you set this to true here, you don't get an error about this declaration, even though it also gets a default type of any. For variables, this is okay. For parameters, it's not okay. Why is it okay for variables? Because what TypeScript does for variables, what is possible for variables, what's not possible here because the function is created first. Here, TypeScript is able to track the values you assign. You see, okay, I got logged here like this. Now I set it to true. So therefore, thereafter, if I console logged here, it's a Boolean. So TypeScript is here able to understand the flow of your code, and therefore you don't need to be precise regarding the type here. Of course, you want to be precise if you want to avoid that you can freely assign a new value, which you can do here because it is of type any. So you want to still assign a type to avoid this. But TypeScript is at least able to find out if the code you're calling works with the type it currently holds. That's not the case here because there the function is defined before you call it, and therefore TypeScript would have no chance of knowing if what you pass in there can be used inside of the function. Strict null checks is another important option. It's actually related to our button selection, which we have here. Remember, I had to add this exclamation mark here to make it work, otherwise I'd get an error. Now we can also get rid of that error without adding the exclamation mark by setting strict null checks to false. So let's do that here and let's save this. And as you see, this error is now gone here and I can compile all files. Now what do strict null checks do? They tell TypeScript to be pretty, well, strict regarding how you access and work with values that might potentially hold a null value. And button here might be null. It's not always pointing at a button element. It's not always pointing at such an element because even though you have such a selector here, a button might simply not exist on the page on which this script runs. And therefore, TypeScript can't tell because it's not diving into your HTML file and looking at that. It can't tell whether this will be successful or not. And if this fails to return a pointer at a DOM node, then it will return null or undefined to be precise, but that's treated equally here. So therefore, then button might hold a null value, and therefore this code could fail. Indeed, if I comment out this button here, if I now compile everything, it works because I disabled the null checks. But I therefore now have a runtime error because I can't call event listener, add event listener on null. And I got null here because I got no button. Now this is a mistake we could avoid by setting strict null checks to true. And that's automatically set if we have strict set to true, where TypeScript anticipates that this might happen and therefore forces us to work around that. Now, one cheap workaround is this exclamation mark operator here. This tells TypeScript that you, the developer, know that this button exists or that this operation will yield a non-null value. Now, maybe you do. You certainly do if you know that you are working on the HTML code and that there is a button here, that this selector here will work. So it would be fine to use the exclamation mark in this scenario. If you have another scenario where you don't know for sure if it works and you just hope that it works, then it might be better to simply wrap the code that might fail in an if check, which will be there at runtime as well, of course. You could simply check if button is truthy, which it won't be if it's null or undefined, and move that code into this if check here. Now, even without the exclamation mark, in strict null checks mode, we get no error because TypeScript understands that this code is inside of this if statement and that this if statement makes sure that button is not null and that this will not fail. So this might actually be the cleaner workaround. However, of course, to save code, if you know with certainty that something does exist, using the exclamation mark is shorter and an absolutely fine option. Here I set both so that we see both. Of course, you just need one of the two things, either the if check or the exclamation mark. Strict function types here is a little bit of a more advanced setting, catching some niche bugs which you might not have in many applications. It is related to, well, function types you might be setting up. So not types inside of functions, but if you define how a function should look like regarding its parameters and return value, and you create such a function type, which you learned about in the basics module, then there you can introduce bugs if you work with classes and inheritance, which we haven't learned about yet, which we haven't used yet, and therefore for now let's ignore this. Strict bind, call, apply. That can be helpful if you do work with bind, call, or apply. For that, let's quickly see an example. Here we have our button and our function there. Now let's say this would be a function which we define here with the function keyword or as an error function. Doesn't matter. I'll use the function keyword here. Click handler. And in there, I console log clicked. And now here we point at click handler. And for some reason, we want to make sure that when this executes, we pass in certain arguments or we set the this keyword in there to a certain value. Now let's say here we do expect a message argument, which should be a string, and we want to output this here as well. Now, since click handler is passed to add event listener like that, so that the browser basically executes this for us, if we want to pre-configure the arguments which will be passed in, we can use bind. And bind as our first argument takes what we want to bind the this keyword to. And here we could say that does not matter to us because we're not using this in this function, so we bind it to null. Now you see here I get an error. I get an error that can be avoided if I set strict bind, call, and apply to false. Now you see the error is gone. Now what does this option do therefore? It basically checks on which function you're calling bind, call, or apply, and it checks if what you're setting up here makes sense. And here TypeScript sees we want an argument, we want a parameter in click handler. With bind, we're not configuring that though, and therefore here we get an error. If I set this back to true, or I just commented it out, because of course it is set to true by default by setting strict to true, we therefore get the error again. Now if we wouldn't expect an argument here, you see the error would be gone down there if we also remove the message, because TypeScript understands our code and sees you're not passing in any arguments to that method or to this function because it doesn't take any, so that's fine. But of course here we want one, so we get an error. The solution is to provide this second argument here, which is the first argument we want to pass in. Now, TypeScript is really smart here, and for example, if I pass in a number, it would still complain because it understands that I need a string here. If I pass in a correct string though, like you're welcome, then it does not complain anymore because now it understands this and it sees that this is matching my function definition here. So this is a very useful behavior that makes sure that you don't accidentally use bind, call, or apply in a way that does not work with your code. Now, strict property initialization becomes important once we work with classes. We can ignore it for now. No implicit this also does not matter right now. It has to do with the this keyword, and TypeScript basically tries to warn you if you use the this keyword in a place where it's not clear what it refers to. And always strict simply controls that the JavaScript files which are generated are using strict mode, so that this is added. With that, we covered all these strict options. Now if we move on, we got more options. No unused locals, no unused parameters, no implicit returns. This helps you with code quality basically. TypeScript will complain if you have certain unused variables and so on. So if we turn these three options on, for example, this option helps you with switch statements where you might forget the break keyword. But if we turn these three options on, what TypeScript will complain about is, for example, if you had a username variable here locally in this function and you don't use it. You see, this has yellow squiggly lines because it's not an error really, it's more like a warning or a hint. So if I compile here, you see now, however, I do get an error because TypeScript only knows errors. And there we see that username is declared, but its value is never read because we made sure that we don't want unused local variables. unused global variables, so if I had something like app ID here, are allowed though because TypeScript can't know if you maybe need that globally defined value in another script file. So therefore this is allowed, but in a function where there is no other place where you could need it, TypeScript will complain now if you have unused code. And that's generally a good idea, allows you to strip out such unused code. Same goes for unused parameters. If you would take a age here, for one, of course, bind is broken now, but even if we pass this in, this works. But now again, TypeScript and therefore also the IDE tells us that this is unused. And indeed it is, so maybe we should remove it or start using it. So that's no unused parameters. And no implicit returns means that we'll get an error if we have a function that sometimes returns something and sometimes it does not. Let's say we have another function, add, where we get two numbers, number and 2 is a number. And of course we can return n1 plus n2. But let's say we're for some reason checking if n1 plus n2 is greater than 0, because we only want to return if we have a result greater than 0. And then we want to return the value, otherwise we want to return nothing, we don't want to return. Well, then we get a warning because of that extra setting with no implicit returns. TypeScript detects that not all branches in this function lead to a return statement, and because of our setting, that's not allowed. We at least have to deliberately not return anything here by adding the return keyword. Just omitting it is not allowed here. It is allowed if you have a function that does not return anything in no branch, but if you have at least one case where your function does return something, then you have to make sure you return something in all cases. And with that, we're nearing the end of this config walkthrough. We can ignore the module resolution here. All these options actually are pretty advanced. They don't matter to us here, don't matter to you in a lot of projects. Source map options allow you to tweak these source maps we had a look at earlier. So these translation files from JavaScript to TypeScript. Typically, default settings should be fine here. So if you don't know what you're changing and why you're doing it, you typically don't need to change anything here. And regarding these experimental options, I'll have a look at them, specifically at experimental decorators, later in the decorators module. This basically enables certain features to be used in TypeScript which are really experimental, where it's not sure if they will end up in JavaScript at some time in the future, and where you still might want to work with them. Then you explicitly have to tell TypeScript that you want to work with these features, and you can do that with that configuration, but again, I will come back to that. And therefore now, we walked through this file, a lot of options you can set there, and as TypeScript grows, you typically also get more and more options added here. Therefore, the official docs are of course always a great place to dive deeper and to make sure that you don't miss an interesting option that might help you in your project. So now that we have a properly configured project, let's dive a bit deeper into how you can debug your project or how you can have a great development flow. I showed you my basic IDE setup at the beginning of this course. Really make sure you got the right extensions installed. There, for TypeScript, it comes down to ESLint, which can help you with linting your TypeScript code, so with improving the code quality, though you might need additional configuration for ESLint to have an effect. It can help you in more advanced projects though. But more interesting than that, you want to really use Prettier to automatically format your code and have a nicely formatted code. And you might want to give Debugger for Chrome a try, because that allows you to debug your TypeScript files even from inside VS Code through Chrome, but without using the Chrome DevTools. Of course, you can use those as well. As you learned, if you do enable source maps here, which you can of course always do, you get these translated files there as well, which is really nice. But you can also use VS Code. You can place breakpoints here, let's say in the click handler. And now to launch your files here through VS Code, you need to enable source maps as well, but we still will be able to use VS Code instead of the browser DevTools. So enable source maps, place your breakpoint, and then go to debug Start debugging. Now, the first time you run this, it should ask you for an environment, and there, with that debugger for Chrome extension installed, you should be able to choose Chrome. It will now go to a launch JSON file where you configure how it should launch that. And there you should point it at localhost 3000 because that's where our development server is running. And of course that process, so the npm start process, should be up and running. So point at localhost 3000 there. And as a web root, you can leave that placeholder here, which means this project folder is assumed to be the host of your files, which is the case. And now compile your code so that the source maps also are generated after setting the source maps config to true, so that we now have these in the JavaScript code. Then with your breakpoint added here and your launch JSON configured, let's run debugging here. Start debugging now for real, and it will open up a new tab now automatically. This tab will be closed whenever you quit the debugging process, or if you close the tab, the debugging process will quit. So now with that, you enter this debugging view here in VS Code, where you can track variables, watch certain expressions, and see the current call stack. And if you now click on Click Me, you should be taken back into the editor, and code execution pauses at your breakpoint in the TypeScript file. And now you can walk through the file here, inspect local values for the this keyword or for the message variable, for example, script-wide variables you might have, and global variables you got access to, global objects. You can watch certain expressions like message plus multiple exclamation marks, and well, then you can always track the value which is in there here in this window if you wanted to, so that would work. And you can see the current function call stack, for example, that we're currently in the click handler. And now you can step through your code with these controls to step to the next step, skipping over the next function call, stepping into the function call, or stepping out of the current function call. And the call stack, of course, here will adjust according to that. And with that, you can ignore this browser sync thing here. With that, you can always resume code execution by clicking the play button and only pause whenever you reach your breakpoint the next time. So this is how you can debug code. You can remove a breakpoint by clicking on it. This is how you can debug code from inside VS Code with the help of the built-in debugging tools, the Chrome debugger extension, the right configuration, and source maps, which are set up in your TypeScript config. And that's it for this module. We had a very detailed look at the TypeScript compiler, how you can configure it, and how you can make sure that it really compiles your code the way you want. We had a look at all these different options, especially the strict options really allow you to write correct code and not run into strange bugs, strange runtime bugs you might face, for example, with the strict null checks. And in addition to that, we had a look at debugging, how you can easily configure Chrome and VS Code such that you can debug from inside VS Code. Debugging from inside Chrome with source maps and the sources tab, of course, is always an option. The key here also are the source maps, which you are configuring to be generated in the tsconfig file, which are these map files that live next to your JavaScript files. They basically act as bridges for the debugger between your JavaScript files and your TypeScript files. And with that, we know a bit more regarding how to manage our projects. Let's now see what else we can do with TypeScript and JavaScript.